Welcome you all to the 10th Leipzig Semantic Web Day, the LSWT 2022 at the Data Week. So we are very proud to organize the LSWT for today, and we were a lot of organizers, co-organizers from various institutions, and mainly we were people from the AKSW working group, from the DBpedia working group, also from Essenza, which is also my employer, the INFI, and the University for Applied Sciences in Leipzig, and the Technische Hochschule Brandenburg, University of Applied Science. And the LSWT as Semantic Web Day in Leipzig has emerged in 2009, where we had various project presentations and also a lot of industry talks. And so now we have 14 years of LSWT, and it's the 10th LSWT. In the meantime, we also had the semantics conference here in Leipzig, and 2 times. And we also organized a workshop and the Informatik conference in Chemnitz, so there was like a little bit of a break in between where we had enough other events to do, or where we somehow put the LSWT into the other events. And in 2018 with the LEDS project, we restarted the LSWT, and now we are at the 10th LSWT, and now we are very proud that we are co-located with all of these other events in a complete data week, and not just one Leipzig Semantic Web Day, but a whole data week. So I will briefly introduce you to today's program. Now we're at the welcome session. I forgot to introduce myself. I'm Nathanael Arndt. I'm Senior Link Data Expert at Essenza GmbH. And after my introduction, we will have a keynote from Dr. Sebastian Philipp Brandt from Siemens. All are here. And directly subsequent to the keynote, we will have a session about sustainability and analytics, which is chaired by Professor Vera Meister from the Technische Hochschule Brandenburg. After these talks, we will start with the minutes for future knowledge experts. The future knowledge experts, as you all know, you have been at the university before, or you have learned the things you're doing now. So we have quite some people from the universities for applied science who are involved in the LSWT organization. Also the students from HTWK are doing the video broadcasting for us. Many thanks for that. They will present posters in the Wandelhalle outside, which you can briefly get to know during this short session, during these minutes, and then see in the coffee breaks. Then we will have a session about data acquisition and data sovereignty by Michael Martin, chaired by Michael Martin, Head of Competence Center at the Institute for Applied Informatics. Then we will also have a lunch break. In the next session in the afternoon, we will speak about collaboration and ontologies, chaired by Professor Thomas Richert from the Leipzig University for Applied Science. Again, a break and knowledge graph application. So I think you see that we have a quite packed program, and we have very interesting topics which all span around the semantic web. And the knowledge graph application session, which is chaired by Dr. Anthony Delpoich. I've seen him also. There. And last but not least, we will conclude today here in the town hall with the Essenza Poster Winner Awards and closing. So overall, we have 17 speakers and we have 12 posters. And you, as our audience, are selected to vote for the posters, so we can give to them an Essenza Best Semantic Web Poster Award and an Essenza Best Design Poster Award. You have 2 dots in the back of your name card, a red one and a green one. The green one for the Semantic Web Award, the red one for the Best Design Award. I'm sorry if you have a red-green issue. Please ask someone else to select the correct sticker, or you just do it randomly. I've also put the colors on sheets which we put outside. And as I said, with this award ceremony, we will conclude the day here in the town hall. But after the day here in the town hall, you're cordially invited to the ScaDS.AI Living Lab tour at 4:30 in the Living Lab, which is located in the north of Leipzig, over here. So if you're not, if you don't know the Leipzig very well, this is the town hall over here, and there's the ScaDS Living Lab, where you will see a lot of demos, sessions, and posters and demonstrations. And after this, we ask you to come back to the south of the city center again to join us at the Essenza Semantic Beer Garden in the wonderful atmosphere of the Moritzbastei. So I want to thank all of my co-organizers, which are Andreas Both. He had to go to another conference. He was here yesterday and will be here on Friday again. Julia, standing there. Michael Martin over here. Professor Vera Meister sitting there. She will chair the first session. Thomas will arrive in a couple of minutes, I guess. Nieves is sitting at the welcome desk at the moment, and Dr. Sebastian Tramp over there. So now let me introduce Dr. Sebastian Philipp Brandt. He is Senior Key Expert for Knowledge Graph and Data Management at Siemens. Sebastian Brandt is senior. His prior research to Siemens was that Sebastian was working extensively on ontology-based knowledge representation systems for the life science in the biohealth informatics group at the University of Manchester. His research on subsets of OWL, which I guess all of you know, with efficient inference problems has opened the door to the OWL-EL facet in the ontology standard OWL2. Sebastian Brandt now is Senior Key Expert for Knowledge Graphs and Data Management at Siemens Technology, the Global Research and Development Center of Siemens. Apart from research, Sebastian is helping Siemens business get most out of their data across the entire product lifecycle. This involves the creation and maintenance of industrial knowledge graphs and their deployment in real-world production scenarios. So, welcome, Sebastian. The stage is yours. Achso, sorry. Ich dachte, alles ist universell bei dem Bus heutzutage.
Ich bräuchte nur noch den. Perfect. Thank you very much for the kind introduction. In all those years that I've given talks, nobody has ever bothered to tell the audience what I've done before, so I feel really honored. Thank you very much. When I meet friends and tell them I work at Siemens, they say, "Oh yeah, you make washing machines, right?" So without trying to be pompous, let me just briefly remind you of a few things that Siemens does as well. And nowadays there are 3 Siemenses, so to speak. So we have the main organization, if you want, and then the Siemens Healthineers and Energy, and if you wanted, you could arrange what they do along an axis of, problems in modern developed societies, where we basically cover everything from healthcare, dealing with population growth, aging, to core industry values, and everything basically from design, production, planning to, in particular, dealing with energy. That means both energy creation, so for instance in terms of some parts of fossil fuels, wind power, and also distribution of energy in terms of electrical grids. And maybe as a bit of an illustration, Siemens provides tools along the entire, let's say, infrastructure value creation. So we build tools to design equipment, we sell, design, build, and sell everything around doing the actual manufacturing in a factory setting. And if you want to spin this example further, we also provide the infrastructure to use those products if they're based on electricity, on other kinds of information systems. And many of those who've come here by train or airplane will have used Siemens equipment, so a lot of the rolling stock that is running, especially in the faster trains in Germany, is made by Siemens, the north of Munich, and a lot of the equipment on aircraft as well. So here in the picture you see one of our aeroderivative gas turbines, which we've acquired from Rolls-Royce originally. But let this be all. In order to work successfully, what these businesses need is they need to be able to work efficiently, not only in one specific part of what they do, but along the entire product life cycle. And I've got an example for you for a product life cycle. This is from switchgears. So if you open one of these boxes on the lower right that you might have seen in the street, behind it there is equipment to transport quite high-powered electricity, 24,000 volts, round-ish close to your doorstep, and then power it down and make it usable for ordinary households or buildings and things like this. And this is a nice example because here, what I'm trying to show here is that the process of building these things starts with a product lifecycle manager. That's this PLM box on the left, where somebody needs to have an idea of what we need for a next product, what properties it has. This gets passed over to R&D. They actually do the heavy lifting of solving the equations, building the thing, or at least designing it. And in the operations, we would have everything from the actual manufacturing to keeping things going once they're installed. And before we can keep things going, we need to sell them to customers, which would be the sales region. So everything that is there has its mirror image in data. So if you want to step back to the first point again, the PLM people, they have their own things to worry about, such as market trends, what kind of technology is user-friendly, is economically friendly, the environmental and sustainability part is getting more and more important there. On the R&D side, again, we've got much more in terms of design documents, in terms of technical and legal requirements that need to be there in order to sell in certain markets. And when it comes to operations, we have the whole thing all over again. And previously, when we look in any industry, actually, not only at Siemens, there has been a trend to have separate kind of concerns in all of these elements of the product life cycle. So you could think of it as data silos or something like this, where the people were just only talking to each other when it was about delivering results or registering requirements, but not really sharing the entire data set. And the reason why semantic web technology and knowledge graphs appeared on the scene at Siemens is really not at all some kind of immediate attraction. My experience in industry is that knowledge graphs are the least sexy technology you can imagine. Nobody walks up to you and says, "Oh yeah, I've heard of these knowledge graphs, they're so nice. Can I get one of those?" It's rather people really fail to solve their problems with any other means, and then they somehow realize that there must be something else out there. And this is exactly the situation that we had at Siemens. So initially, Siemens was involved in research projects about the topic. In this case, well, my kind of memory starts somewhere in the middle of the Optik project. When I started at Siemens, there was no such thing as a senior key expert for knowledge graphs. So the common idea was this is more for, for fun, and when we want to earn money, we go back to databases or something like this. This has changed a lot in the need to integrate what we know about a domain or about a product around its life cycle. And I'd say that here's also a good example with Optik. So when you do something properly, you also get something out of it. So when you do a research project, that's my advice, just do it for real. Don't only do it for, keep on doing what you always wanted to do and sell it under this under the banner of this project. We've worked very hard for Optik and got the first real recognition also inside our organization. And what was nice in terms of timing is that this sort of like overlapped with the ramp up of machine learning, which is to some extent the opposite, right? It's everywhere in the press, and we get the machine learning experts at Siemens get lots of exposure because everybody wants to try this because it's so cool and does all sorts of nice things. But then when you want to integrate it into your processes, it turns out that it's not always as easy, which brings me back to this knowledge graph topic. So roughly simultaneously, so in these 2015, 16, 17 years, we also saw a lot of startups appearing on the scene, and around that time we managed to get the first productive use of knowledge graph out of the door inside Siemens. This was about medium-sized gas turbines, so a real technical subject, not something where you would say, yeah, that's what knowledge graphs are good for. It's not like, what I'm trying to say is that it's not like we modeled who's a friend of who, or who has the same interests in their private life or something like this. It was a real technological challenge to put out there. And since then, as sort of like, as I've tried to show on the lower part of this slide, investment inside of Siemens has grown steadily. So now we have a proper department, so to speak, that deals with knowledge graph applications and with the connection points to standard databases, data acquisition, workflows, and machine learning and visualization and other things. With the growth, we also face the need to standardize things better. So this is why in recent years, colleagues of mine have started to standardize the information model and the vocabulary behind these knowledge graphs, so ontologies. And this, to some extent, I think, bears witness to the fact that the technology is taken more seriously. If people really actually invest money to say, please help me say what I'm talking about when I do my business. It's not the first thing you do when when you don't take something seriously. Here's just a very small overview of what the main building blocks, the current snapshot of the Siemens ontology library. This is actually comes in three parts. So in the first place, we have an infrastructure to share and use ontologies. We have modeling guidelines for people who are bring their own domain knowledge onto the scene, and we have very, very well-trained experts to deal with the upper ontology core, because if you mess up there, you will mess up by transitivity in the whole process. Here we cover basically everything from industrial standards, things that are known in the ontology space when it comes to modeling industry, domain, to, in a sense, the mirror image of all of these business units that I was talking about, so building, energy, rail, and so on. And so this is all good. So far, so good. What I want to spend the last 2 slides on actually is mentioning that it's been a rocky road up to this point. And my feeling is that the difficulties we faced in reaching this point in the distribution and utilization of a new technology that is essentially a brilliant idea can be an example for other application areas for semantic web technology. So, where's the difficulty? Here is I've tried to do something like to orient the problems that we had or the challenges that we faced on some kind of a grid here. So in the center you see this ontology library thing itself, and there the problems already start. Even if you do nothing with the whole thing, you may not find the skills, so finding people who know what ontologies are and how to build them, they are far and few in between. Tools has always been a difficulty in the semantic web domain, I think, and still is. There's lots of personalities involved when it comes to bringing individual parts of the business on board. So people say, well, okay, if I bring my knowledge, I want to have control over how it looks like in the end. And it might be difficult to accept for people that in the shape of the artifacts we build, it looks really strange. But anyway, my favorite pain point is processes, actually. So this is another, we can go in the discussion about it. There's another issue I have with the semantic web as a history, let's say, and as a development. There's too little concern about processes and too much focus on tools and technologies. But once you've overcome all of this, you move into these different axes. So when it comes to the overlap between industrial realities and standardization, somebody walks in and has a very good point and says, I need IEC 81346 in order to say what I do, so please put this in somehow. So we have this problem that we need to relate to standards and somehow incorporate them into our models. But even if we succeed doing that, there are other ontology models on the right that are already existing that we don't have editorial control over and that we somehow need to connect to. This ontology thing on the upper right, this is particularly broad in the life sciences, where we have very large, very well established, very well legally backed ontology resources, and we need to work with them somehow. And going down this interoperability thing, we need to this comes to processes now, so we need to embed all of this fancy new technology into our information landscape. This means I will have somebody walk up and say, right, so how do I connect to MindSphere? How do I connect to Teamcenter? How do I connect to my in-house production system and all these kind of things? We can't say, oh yeah, we can work this out. Maybe you want to have a new system that supports this new technology. That's not going to happen, right? You have to work with the situation that's there. And finally, also on the code development side, we have massive amounts of software developers who do brilliant work where you just can't say, oh yeah, why don't you all go away for a few months and learn this new technology? So we have to help them adopt this as cleanly and as simply as possible. And yeah, once you are around all of this circle, there's a bit of, you really have the feeling that a lot has happened, and I'm in the nice position now that this technology here that we're talking about is being taken really seriously. Also, when I meet other players in industry, I really see that a lot of investment is happening there beyond just, a little project with someone to see what it does, right? So it's more about having the next big attempt of solving the data integration problem where normal relational data integration has completely failed. The last, if I can just show you my last slide. It's a little bit provocative at times, but my own rationale at times is also that a few lessons need to be learned and we need to learn from a few mistakes. So one of them is there may be parts of your business where you don't need all of this stuff, right? Where you don't need ontologies, knowledge graphs, or machine learning, all these kind of things. There's actually, he's at Microsoft now, a well-known data scientist who said, you may just need a group by and a count. And on the other hand, if you do realize that that knowledge graphs is what you need for your business, you are very well advised to choose a technology that does this. And now that the public perception is sort of like putting the spotlight on this technology, what we perceive very much at Siemens actually is lots of people run around and rebrand their tools as knowledge graphs or some kind of semantic web technology and say, yeah, that's the same thing sort of. This is in a way like if your main business is making lawnmowers and suddenly everybody wants bicycles, you might say, well, I've got an idea. We can get into business there. And this is, in a way, I guess, for everybody concerned, a recipe for disaster. And if you want to do it right. And the other thing I briefly wanted to mention is within Siemens there is a certain difficulty in investing in a completely new technology, and ultimately you have a choice between saying, yeah, okay, we do this in-house, we've got enough expertise to build our systems our own, or to say, yeah, there are these nice vendors out there, why don't we buy a product from them and we're done. And when it comes to calculating the risk, in any large enough organization, there will always be a bias towards buying a ready-made solution. Legally, economically, you can calculate the worst-case scenario much more easily. But in my view, there's a problem. In the first place, a lot of the semantic web technology business field is still has a business model that's very much consultancy oriented. So they will send you all of these, hordes of clever people who take notes, and then they go back, and after a few months they come back with this wonderful system which is completely closed, you have no control over, and might not be connected to your processes in the way that you want to. So this is problem number one. Problem number two, this is the one that will be already flagged up by the risk manager. Median lifespan of a tech startup is 5 years these days internationally. So what's your plan for year number 6? And the other one is that, again, when you do this, there's a real danger to be biased towards technology rather than processes. You buy something really expensive and it does these nice things, and you've seen it in the brochure, these wonderful graphs. And you forget, like, okay, how do I get my data in? How do I keep the data up to date? How do I do quality assurance? What legal statements will I have when my business unit sells to customers and things go wrong? All of this kind of stuff is usually ignored. And it's been a bit of a rant at the end, but I think that's the end of my talk. So thank you very much for your patience.
Thank you very much for this interesting keynote and this whole walk around topics of ontologies. So we're at the core of Semantic Web Day. Do you have any questions to our keynote speaker? Yeah.
Thank you for your talk. You had this beautiful slide with all the ontologies in the cloud. And how do you choose your core ontologies? Is there a process for that, or do you just choose the first one that kind of fits and then work with it?
So that's a very nice question. So the short answer is we took all of them, really. So when it comes to ontologies that are covering industry needs, you have very little choice, actually. And there's a real difference when you look in the life sciences. So in the biohealth domain or in medicine, there would have been a rich choice really to start from. In industry, so number one is there's not that much out there, and the other problem is that a lot of the attempts towards, let's say, taking ISO standards and making ontologies out of them get commercialized instantly. So somebody puts them behind the wall and say, no, I can't show you this, but you can buy this from me if you want to. And the problem with ontologies is that they are information artifacts, right? So you can't easily say, oh yeah, have a look around, and if you like it, you can buy it or something like this, unless you think about the process of keeping it up to date in the future, but few people do that. So the blunt answer is we just started from everything that looked usable. We had very nice collaborations with the University of Oslo and DNVGL, actually, who do a lot of work behind paywalls, unfortunately, to standardize these things, and then we went from there.
Thank you for the interesting talk. You just mentioned the word standardize, and to my students, I sometimes say, if you speak about a lot of standards, then there aren't standards. What is the standard? What means? What is in Siemens meant by standardization? And do they are some authorities or things like that?
The word standard has been used in many different ways here. So I guess there is in the first place, the main kind of standard that we are driven by is whatever is used by a business unit to deliver things to their customers in the proper framework. So, for instance, when you sell one of these switch gears in Asia, your switch gear has to fulfill certain technical norms. In order to fulfill the technical norms, you have basically core technical properties, but in addition, you also have requirements on the design process of this artifact. And the design process then leads us back to how have I done my housekeeping with information about building this kind of thing. And this is an example where we get requirements for standardization about how to talk about these switch gears from a business, where if we don't do this, they can't sell their product to this market. So this is a very, very strong kind of requirement. However, the kinds of requirements you actually get, they are called standards by the business unit, but they are extremely heterogeneous, right? So it depends on legal bodies in different parts of the world who say you need to fulfill this in order to sell your product. And then all the way on the other side, I guess, we have a source for standardization in the information systems that are pervasive at Siemens. So lots of the processes in business units are built on some class of SAP systems, Teamcenter. It's just a software company at the end of the day, but the way they organize their things forces us at least to relate to them in some way, so that not extra time and money is spent translating things when it's supposed to be used by these kinds of systems. And in a way, for me as a knowledge representation person, these two types of standards that we've now talked about are the least interesting ones. Right? They are like the day-to-day pressure that I need in order to deliver my work. For me, the most interesting idea of a standard is actually a way of representing what I have in terms of product knowledge, so that I get the best kind of share between different models, share between different business units, and also ultimately share between solutions. For instance, when we deal with data quality assurance, it's extremely time-consuming and expensive to do things all over the place, again, while ultimately all you are trying to do is finding outliers in the distribution of numerical values and then tracing back to, let's say, more discrete situations of where they came from. So it's a bit of an evasive answer, I'm sorry about it, but the reality is that we have lots of different aspects of standardization that we are driven by there. while you walk, if you are a student or a researcher in this area, you may want to talk to me, because this area is growing in industry everywhere, and if you are interested, find me somewhere.
Okay, thanks a lot for the interesting talk from my side as well. And kind of connecting to the first question, I wonder how much of these ontologies and actually of the methodologies that you develop in-house, so to say, flow back to science and to the community, to conferences and so on, and where to find that, so to say.
In the lifespan of this work at Siemens, I would say we are still at a relatively early age. So we do, at the moment, I guess, we are still in an area where we learn, in some areas, more from the state of the art in research than what we contribute ourselves. But this balance is slightly changing, especially in the sense of focusing on use cases that may have been overlooked in the scientific community. So when it comes to ontologies and these things, my colleagues are actually in discussion with standardization bodies to actually also release ontologies rather than, just 500 pages of PDF documents about ISO. This is a slow process. It's also a slow process that involves a little bit of political clout and, patience. However, my personal impression is that we are still in a situation here when it comes to these knowledge representation fields, that a lot of brilliant ideas are floating around in the research space, but researchers may not be aware of the kind of primitivity of the problems that we are facing in industry, or the kind of weird mix of application areas that we are facing in industry. And I have when I'm talking in scientific communities, I often get a lot of surprise in, oh, is this really what you're worried about, or this is not something, are you still at this point? And I guess for me, the best case scenario would be to start really with improving this line of communication. Because currently I feel that there's a huge demand for this kind of knowledge graph and friends technology in industry, but research is at times going, at least from my really egoistic industry perspective, in a direction that makes it more difficult for me to use, or makes it more difficult to map to my actual use case.
Okay, so we are very happy that with the LSWT we provide the opportunity to draw this line between research, science, and economy, business. So I also just recently went to the business side from research, but we are very close to research there. So yeah, I also see this need. So my question would be, like, maybe you said it, maybe I need it a little bit more clear, but what would you say would be a good process to get ontologies as a shared vocabulary also in the industry space, which is like, is there an opportunity to share it like we do it with ontologies and vocabularies in research areas? Or are there so many complete different aspects to care for that they always need to be behind some paywalls or in some restricted area?
So I really hope that there will be a lot more exchange and a lot more standardization, and my feeling is that there really has to be a sort of common denominator of things that I would like to exchange with you as some other industry in order to simplify processes, right? It's, we do the same with database schemata and with core descriptions of how our devices work. So if you're provider of, let's say, computer chips or electronic parts for Siemens equipment. To some extent, I have to tell you what these devices do that I build in order for you to, come up with the right products. And in a way, I see this similar with ontologies. You can't completely hide everything you do. There is a certain level of technical detail from which I think it's natural that people are a bit reticent about it. I've talked to an aerodynamics engineer who said, if somebody knows that we have this column in this table, this is a problem for me. And but we don't have to go there in order, so currently I think the utilization of ontologies or knowledge models there is so primitive that we have so much to gain until we reach all of these danger zones there. And the other point I wanted to make here actually is I do really see a difference in the way ontologies are used as opposed to 10 years ago or 20 years ago. So I work in this community or in this area for a long time already, and when I started, everybody said, yeah, first you need to have the conceptual model and you have to, have to sit down and get it right, and then the life science people tried to do exactly that and took 15 years in order to. So is this a process now, or is this phenomenon? And then the other ones would say, is this tissue, or is this an organ, or is it actually a transport process? So we never really got there, right? And then the other, similar discussion was, should we use these constructs in this ontology or not? Or is it too complicated? Or maybe nobody understands it, right? What's a reflexive, transitive property? With this, my feeling is that with this kind of knowledge graph topic, there's a kind of a rebalancing of the importance of data versus importance of conceptual knowledge, and also a kind of decoupling of this process. So I can start building vast data sets and examine them, and in examining them get ideas about what to do with them, in parallel to conceptualizing everything and packaging it nicely so that I can give it to you, and that your queries work, or your dashboards work, or whatever. So this is something that has really liberated the community, I think, that we're not only talking about ontologies these days, but that we're talking about knowledge graphs as a kind of complete whole where we have a dynamic transition of the way we represent the data, and some of it gets reflected in terms of ontologies, but other things might not be. So that's I see this as a great step forward already. We would not be here, I guess, if we were still trying to conceptualize everything before we put the data in.
Thank you for this answer. Any further question? I think we have time for one more question. And then, if not, okay. You start and you end.
You also talked about best practices and guidelines on building ontologies.
Mm-hmm.
Do you publish those guidelines or best practices somewhere, or are you relying to some best practices that are already out there?
So the people who started with this project within Siemens have decades of experience building ontologies, so they brought with them a certain baggage of how to do things. But let's say there is a long addendum to how you do this inside an industry and knowing about the Siemens processes. So a lot of so there's, in a way, you could see these best practices as one half about modeling guidelines that are universal to some extent, I guess, and the other one is how to build your own ontology in a Siemens-like setting. And there's a certain amount of working knowledge about how our business units organize their data, who makes the decisions, and who would be the person to talk to, stepping back from day-to-day operations a little bit. So in that sense, it's a little bit of both. And what we do, I guess, as the technology, there is a little bit of a consultancy role. So we go in and say, okay, what do you do, and where's the pain point in terms of sharing, organizing data better, and then starting from there. I personally don't believe that an ontology is completely specified by its application domain only. So if you say I have an ontology about trains, this is not good enough. So you really need to know a little bit more about what to do with them in order to have any hope of succeeding there. Yeah.
Thank you very much, and thank you for all of these answers and this interrogation between you and the people. Okay, as you're my boss, you're still allowed to give another question.
Otherwise, just talk to me. I'm really honored by the interest here.
I have a more general question from the use cases you already have in production at Siemens. What do you think is the best fit to the attributes and what knowledge graphs can be compared to what we all think they are be? So, I mean, I talk about is reasoning something which you are often used, not often so often used? Is the linking aspect something you which fits more to your use cases? So,
how much? This is a topic in its own right. So I try to be fast. The killer application of knowledge graphs is data integration. We blow everybody out of the water who has tried data integration with any other means before. So no, really, hands down. I take nobody else seriously in that respect. This is the killer application. Number two is knowledge graphs open the door to a kind of data that wasn't even considered data before, right? So highly complex, interlinked, discrete knowledge about how. So what did we do to this turbine blade after we, removed it from this machine and found that there was a depression of this size in the, under the stem. Right? These kind of things were previously just documents, right? And then somebody would maybe take the measurements and put them in a table. And now we make this kind of stuff accessible to, machine processing. And this also opens another door to machine learning, actually. So we discovered that humans are not the only consumers of knowledge graphs if you do your homework right. And this is a very, very exciting thing to do. So that's everything else we need.
Okay, thank you very much again. So I want to hand over to my colleague Vera.
Thank you.
And thank you very much for your interest. And find me anywhere and
Yeah, thank you, and thank you for the last question, because I think this was a really good closing word for this talk. And now we will have a short track of two talks, sustainability and analytics, and we start with a talk from Julia Gastinger from NEC Laboratories Europe, and the talk is called Temporal Knowledge Graph Forecasting. Julia, the floor is yours.
So, hello everybody. I'm very happy to be here today. My name is Julia Gastinger. I am with NEC Laboratories Europe in Heidelberg, and also I'm a PhD student at University of Mannheim, supervised by Professor Stuckenschmidt. And today I'm going to talk about temporal knowledge graphs, and more specifically on learning from temporal knowledge graphs. So I'm coming from the machine learning domain, and we are focusing on how to use machine learning for knowledge graph-based machine learning. Yeah, and this talk is specifically about temporal knowledge graphs. So I'm shortly going to tell you a bit about NEC Labs Europe, and then I'm going to give you an overview of what are temporal knowledge graphs, what we mean by that. And then I want to focus on the area of temporal knowledge graph forecasting. I will end a bit with our research questions and will show you a bit our current tasks. And yeah, in the end, I hope you got an overview of this research area of temporal knowledge graphs. So to start, that you know where I'm coming from, we are at NEC Laboratories Europe in Heidelberg. We're a research laboratory. We focus on patents, publications, European or German projects. We have different research areas, and I'm in the data science. No. In the data science research area, focusing on the multimodal and relational data, or graph-based data. To start with, this image shows you an image or representation of a knowledge graph. And as you probably all know, a knowledge graph consists of a set of entities. For example, in this image, you see Lily, you see Mona Lisa, you see Paris, and a set of relations or type of predicates. For example, is a friend of or has visited. One can represent a knowledge graph as a set of triples in the form of subject, predicate, object, like Lily is a friend of James. In our area, the typical tasks are, for example, link prediction, like who else would be a friend of Lily's, or does Lily like Mona Lisa, or node classification, like what type is Paris, what class does Paris belong to, or also graph classification, like which graph or which class does the whole graph belong to. Now, the thing with those knowledge graphs is that they change over time. In this example, for example, Lily finds new friends, new buildings are built in Paris. James moves places, James is interested in other things. And we want to incorporate this evolvement over time, and more specifically, we want to learn from it. And now this leads to temporal knowledge graphs. Temporal knowledge graphs are knowledge graphs where facts occur, where facts recur, where facts change over time, and each edge or node in a graph has temporal information associated with it. So this is the overview or the definition of temporal knowledge graphs as we use it. And here you see an overview of temporal knowledge graphs, how you can represent time. People in literature do different things. In the first picture, you see that you can have the time in the nodes or in the edges. For example, the population heavily protests the government, or different governments are consulting each other in a period of time, or other things. Another way of representing the time is that you have one graph per time step, which is then called graph snapshots. So in this image, you can see 3 time steps, and each has only the triples present which are known to be true at this time step. Or the third way, which is a bit in brackets because it's a bit different, is to have time in an external model. So you would have a static knowledge graph, and in an additional model you have the events which happen over time. And then you have some joint representation. For the first two, and partly for the third one, what people do is they extend the triples to be quadruples. So they add a 4th element, which is the time, either the time stamp or the time period. And then you can, for example, use a data set, which just consists of a set of quadruples. So why do we want to use those temporal knowledge graphs? The one thing is, why do we want to have the knowledge graphs, or why do we need the relations in the graph structure? The thing is, we want to model relations, we want to model a graph structure, we want to see how, for example, people influence each other, and we want to be able to model different types of relations. For example, is a friend of, is different than is the president of course. And also we want to be able to not rely only on simple patterns like in tabular machine learning, but we want to be able to exploit higher order features, which are captured by the graph structure. And why do we need the time aspect? Because we want to model the time dependency of changes in a graph. For example, some actions happen more often recently and are thus more likely to happen again soon. Or we have temporal fluctuations, we have seasonality, things like this. And the goal is to combine those two ways of looking at things and take both aspects into account and thus learn more, be able to learn more. In temporal knowledge graphs, there is already some research. It's rather new, I would say. There is the area of temporal knowledge-based completion. So, for example, a question would be, you have a graph and you want to ask, when was Obama president of the US? Or for more unknown things, of course. You have graph and node classification with time information, question answering, and this is what I'm focusing on today, the extrapolation to future knowledge graphs. So temporal knowledge graph forecasting. And this is what I want to talk about a bit more now. So, as I said, temporal knowledge graph forecasting is the extrapolation to future knowledge graphs. So you have a history of knowledge graphs. For example, here time steps 1 to 3, and you want to see how the knowledge graph will look like in the future. For example, for time step 4, 5, 6. So you can then do link prediction for each future knowledge graphs to see what will be the relation between certain governments, between whatever you're interested in. At NEC, we have different use cases. We are looking at crisis management, but also public safety and law enforcement, and greenhouse gas emission reporting. Anyway, they have in common that we need to incorporate the information about different types of nodes, their attributes, and the types of the links. We want to predict future links and the entities for a given knowledge graph, and we want to detect the changes in a knowledge graph over time. How we represent time is graph snapshots. As I've shown already before, we have discrete time steps, and at each time step we have one knowledge graph or graph snapshots, which contains all the triples that are true or known to be true at this time step, to then predict for future time steps, one or multiple. This way of representing time can represent different things. For example, events at different time steps, like the police arresting a person, or time intervals. For example, a government which governs a country for a certain interval of time, which is then present at each of the graph snapshots where it's true, or also static facts, like a city being the capital of a country, which is then in the graph or in the knowledge graph at each snapshot. However, they can of course not represent continuous time or anything more fine-grained than the snapshot step size. So it's important to choose the snapshot step size well, depending on your use case. There is already research happening in this area on temporal knowledge graph forecasting. I will not talk in detail about the slide. It's just a list of the papers which are closely related. Code is available for most of them. And yeah, in summary, they all look into the future of knowledge graphs. They represent time with graph snapshots, and they focus on more or less the same data sets. I've listed the data sets here in case you're interested. They differ a bit in their focus. Some of them are focusing on explainability, some want to be extra fast, some want to have higher scores. And they have different approaches or methods to tackle the problem, using, for example, rule-based approaches, graph convolutional network-based approaches, or others. With the state of the art, we have identified 3 open issues, one being the discrepancies in evaluation. So to keep it short, the results are not really comparable across the papers, which is, for example, because of data sets used, of the filter settings used, and about the number of steps that are being predicted. The second thing is that the predictions are not yet super good, so we think that it can be improved. Here you see a table of one of the best methods so far, and the scores could be up to 100 in the last line, but they are not yet. So we think we can improve there quite a bit. And the third point is that the methods are not yet applied to any real-world use cases, as far as the research paper is concerned, at least. And this leads to our research in temporal knowledge graph forecasting, where we want to tackle, we are tackling right now, the following research questions. Namely, how can we improve temporal knowledge graph forecasting? How can we evaluate the methods in this rather new field of research? What insights can we get by analyzing the evolution of temporal knowledge graphs? And to hopefully also generate real-world impact, how can we apply the developed methods to analyze these insights to a real-world use case? Right now, we are focusing on two main things. One is the evaluation of existing methods under a joint evaluation protocol. And the second one is working on a new method for temporal knowledge graph forecasting, taking into account everything we have learned so far. So to sum up, I told you what are temporal knowledge graphs. I told you about our way, or the way of the common literature, to represent time, namely with graph snapshots. Our research interests, namely extrapolating to future knowledge graphs based on a history of knowledge graphs, and the analysis of the temporal knowledge graphs over time. And yeah, I told you what we're currently working on, which is the evaluation of the existing methods and the method for temporal knowledge graph extrapolations based on knowledge graph embeddings. To end, we have always student projects available, so if anybody's interested, I'm happy to get an email. And also if you have any questions, I'm happy to answer them or talk to you about this later. Yeah, and that's it.
Thank you very much, Julia. Are there any questions?
Thank you for your nice talk. Have you thought about already on effects of causality? Causalität. There is a breaking new book by Julia Pearl, where some things are responsible for the future, but a lot of others are not responsible. I saw a little bit few about causality in your talk. Thank you.
So thank you for pointing out the book. I didn't know that. Yes, we have thought about it, and I think this is also something we need to analyze for the forecasting, because some things, as you say, might cause other things. Some things might just have some correlation. So this is something we for sure need to analyze when analyzing the results. Yes, but so far we have not investigated it yet.
Are there other questions?
Thank you for the nice talk. I have actually two questions. One of them is I just wanted to mention that you may not think of this as an interesting problem, but for us what's really interesting is being able to somehow summarize the changes between two different time points in a knowledge graph, because when we use them as information models for some process, knowing what has happened in the meantime without looking at the whole graph is vastly instructive for us. I don't know whether any of the methods would lend themselves better or worse for this, but that would be my question number one, actually.
So this is indeed something which is interesting and which I think none of the methods has at least published in a paper yet. An idea, I think, what one could do is you have the graph embedding, and then you would analyze how the embedding of the different entities or the embedding of the full graph changes. And if there is a significant change in the embedding, this might show a significant change in the graph, which might hint to a significant change in the real life, which you would then analyze. So this is also something we have not yet looked at, and it's a bit use case dependent, I guess. But for example, this either crisis use case or also the carbon reporting use case, there it might be super interesting to look at why has something changed that much, which entities are the ones causing the change, and analyze this neighborhood more specifically. So yeah.
Okay, thank you. Okay, I think last question, because we have a second talk. Please use the mic.
Which applications could you consider in the area of medicine and health in general? So just some examples that you
Excuse me, I didn't understand.
Which applications or cases could you consider in the area of health and medical applications?
I am not an expert on health or medical, but I know in our lab they are doing, for example, they use knowledge graphs to predict protein-protein interactions somehow. And I think one could also integrate a time there when one integrates, for example, when was a medical treatment taken, and how could this interfere in the future, for example, with the patient. This could be interesting. But again, I'm really not an expert on health, so I might not be the person to ask, I'm sorry.
Thank you very much, and I want to suggest that other questions could be given in the breaks.
Yeah.
So we have now, thank you again, Julia, and we have now a second talk by Dr. Sonja Schemler from the Weizenbaum Institute and Fraunhofer Focus at TU Berlin, and Dr. Adamantios Kumpis from RWTH Aachen, University Köln, and the talk is called Fair Digital Objects in NFDI for Data Science and Beyond. NFDI is a very ambitious, a huge project in Germany, and not only.
Okay. Have to post? No, it's okay. I will use it. Okay. So, nice to be here. The plan was initially that Dr. Schemler, the coordinator of NFDI for data science, would be here. At some point, she was not able. She asked me to come here. And then, shortly, last week, she told me that we would be here, both of us. And then, at the end, she didn't manage to be here with us. And I used this opportunity to make a presentation which might not be necessarily the official one that Sonja could have carried out as coordinator of the project. So it is on purpose and deliberately that I will use this opportunity to also raise some more controversial concerns and issues. So the title of the presentation is Fair Digital Objects in NFDI for Data Science and Beyond, but I changed it to pay something like a homage to Douglas Adams' book about life, the universe, and everything, to Fair Digital Objects, NFDI for Data Science and Beyond. And questions, as we all know, are more important in science and research than the answers, because the answers may be wrong or may be considered as correct now, but may be doubted after some time. So what is the asset there is questions. And some questions to ask here is, do we know what a fair digital object is? So could I ask you to raise your hand if you have heard before in the past the term fair digital objects? Who has? So it's not the same to not have heard it. So who has heard about fair digital objects? So there are some people. And now, who has not heard about fair digital objects? So, okay, which is very normal and okay. And someone might care to ask, is there a specification about what fair digital objects are exactly? And FDOs might be, at least for the time, theoretical, and we have to come up with our own working definitions and interpretations. And this is something also that is considered as a challenge for the NFDI for Data Science project. And this is both good and bad. So it is good because it allows us to experience many eureka moments and experiences. And it is bad because not all falling apples spark sustainable, long-lasting, and game-changing innovations. So it might not necessarily be all worth the fuss about it. And okay, it's well known that it takes a village and several years and resources to build something. And Open Digital Rights Language, a policy expression language, was initially created in 2000, and it took about 18 years to get published as a W3C recommendation. And this is not uncommon at all. And what may be uncommon is that other people would have given up much earlier their efforts. And still, there is no guarantee about the outcome of this process. So the question was whether we do know what an FDO is. And actually there is no need to make a philosophical doctrine out of it. It is time to change course, and this is actually what we promote in the project. And the approach is something like following the principle of I know it when I see it. And in this respect, the project offers an opportunity to leave theory for practice. And recently, on the 20th of June, there was an NFDI infra talk where the laboratory, the institute I am part of, the Institute for Medical Informatics, and the team of Professor Beyani and Fraunhofer Field, that are both partners in the project, have built a test case for applying a fast-track approach for FDOs in the health domain, which means that at some point we can or we have to dare for swimming upstream the TRL scale. I don't know if you are familiar with the term TRL, technology readiness levels. There, one may start from the lower numbers, where it is about concepts and basic principles, and the higher one walks or swims comes closer to deployment and actual operational systems. So, there was a German chancellor who was still praised for this quote about whoever has vision should go to the doctor and read the writing on the wall. What could this writing be? I will skip these slides because I think that they will not offer you anything about data science routines that you are all aware of. And okay, one may observe a lot by watching. The EU GDPR regulation sets a major legislative milestone, not only for the areas of data protection, but also for the wider area of data science. And it afforded data subjects with both transparency and greater control, which had an impact on big data, AI, and in many of the areas we are actively involved. Worth to remember that, same as for the real world, there is no nature versus nurture argument to apply for the human-made data spaces. This means that one of the major shortcomings of the GDPR regulation was related to the legal base of consent and how it is typically realized on the web. And here we could apply a hypothesis that we might reverse GDPR as a spyglass so that freely given consent is led by the FDOs, so the objects, the digital objects, and not the data subjects. This does not mean that we lessen the role or importance of the human users, only that we upgrade the role we expect that digital objects will play in the field. And what does this practically mean? So what I said is that only that we upgrade the role we expect the FDOs to play in the field. This might seem like irrelevant, but it is a book written by a philosopher. He was also a visiting professor in LMU in the Center of Advanced Studies before some years, Emmanuel Kochia. And I will read something that was in the back cover of the book. We barely talk about them and seldom know their names. Philosophy has always overlooked them. Even biology considers them as mere decoration on the tree of life. And yet plants give life to the earth. So the idea is actually to upgrade not the role of plants, but the role of objects and the role that they play in the field. And this might be regarded as one of the takeaway messages from my presentation, that we should exhibit with our actions an increased respect for objects. And here it is where fair digital objects may come on stage. And as of today, our stance for objects has been mainly utilitarian. Possibly only the CLAM community, collections, libraries, archives, and museums had a different attitude. Perhaps they were better informed, better educated. This is also part of the challenges in the NFDI for Data Science project, because we consider also capacity building and learning as essential parts of the project. So it's not only about research. With low levels of literacy about data and ethics and AI, the results will not be very much improving the state of the play. And this needs to change. And it will be a catalyst for turning the internet into a meaningful data space, which is the theme of the first Fair Digital Objects Forum to happen this year in the Netherlands. I will mention this at the end. So you can keep this as a first takeaway message towards an increased respect for objects. The second takeaway message is daring for swimming upstream the TRL scale. And okay, who would dare to do this? Who are notorious for ignorance of dangers, risks, and fear? Sebastian, I would say that it would not necessarily be big companies. And from my side, I would also dare to say that it's not also universities or research centers. Usually the ones that are notorious for ignorance of dangers, risks, and fears are startups. Even in case that the place that they find to incubate might be a big company or a university or a research center, it is usually the startups that would definitely dare for swimming upstream the TRL scale. So you can keep this as a takeaway message too. And what I would invite you to do is to keep an eye on the developments and the progress of work of the project, and please feel very comfortable to connect with us and discuss and seek for synergies. And from my side, I will do the same. Therefore, I will attend with very high interest the proceedings of today here. And there is the event, actually, it is the event on FDOs, and it is the first international conference of fair digital objects, which uses the same slogan, if you like, that I mentioned before about turning the internet into a meaningful data space, which takes place in October in Leiden in the Netherlands, and where the call for abstracts is still open, and it has a short deadline, but I expect that they might give an extension. So the deadline is planned to be on the 10th of July, but even with some delays, you can go there and submit. So this is from my side. I will be very happy to answer any questions.
Thank you very much. The floor is open for questions.
Thank you. Thank you for your talk. Could you give us a definition what is fair with respect to an object?
Yeah, actually, fair, I'm not someone who stayed long in this area. So for me, fair, I would understand it as the subject. Fair, like fair trade, but it is the acronym about objects, digital objects that are findable, accessible, interoperable, and reusable. So it's a specific acronym there, but still one may understand actually all these four qualities about findability, accessibility, interoperability, and reusability in a very broad consensus. Yeah?
Are there other questions? Okay.
Is it important for you in this discussion to distinguish between a service and an object, or is that more or less the same?
I would say that the important is that there will be some momentum gained in this field, which means that if it would end up into a debate that would have only academic value and serve only academic purposes, then it might still offer people a space for a debate, which is useful, but it would not necessarily make any change in the field. Which means that I would suggest that we should care more about applying our ideas than living in the golden ivory tower of them, which is very enjoyable, but it doesn't necessarily serve any purpose other our own well-being. But which means that one can still stay in Plato's cave and extend on philosophical aspects, but it's good also to offer to our ideas a reality check, yeah? And usually the ones that can dare to do this are usually startups, yeah?
I have also a question. Thank you for this more or less philosophical talk. As I know, your project started half a year or a year ago. It's very young. And you mentioned the healthcare industry. Is it the one you are focusing first?
No. I mentioned this as an example that we have recently built a fast track on applying concepts of FDOs into the health domain. Otherwise, the NFDI for data science is not focused on the domain of health or on some other domain. It is actually, in this respect, offering services to a wide audience of users.
And is it possible at the moment to give a very hands-on example of such a data object in
actually, I could include in the slides that can be uploaded, but there was an NFDI infra talk which took place before 15 days on the 20th of June, and you can watch there this step-by-step process. Okay?
Thank you very much. So, thank you, and I think I will hand over to Thomas. Yeah. Hast du das Audio irgendwie eingebunden?
Das eine dachte ich ist da.
Ja, der aus Indonesien. Aber die haben so ein Video gemacht, das hast du nicht eingebunden.
Ich hab's da, ich weiß nicht, ob ich starten kann. Ich kann es probieren, ich weiß nicht, ob das Audio klappt, aber müsste eigentlich...
Sonst können wir vielleicht einfach auch das Mikro abspielen, weil die haben das wirklich nicht gemacht.
Just try to get it in another size, but
Und dann musst du, glaube ich, einmal rausgehen und wieder reingehen.
Das kommt gar nicht mehr.
Okay, ja. Jetzt zieh nochmal raus. Hier unten das Kabel wackelt. Immer mal. Und jetzt machen wir wieder rein.
Das sieht gut aus.
Machen wir so.
Warte, das ist gut.
Jetzt habe ich es hier auf dem Laptop.
Ich hab's.
Lass einfach so, wie es ist. Super. Damit können wir weiterschalten.
So, thank you for the short interruption with my technical issues here. So now we are coming to a quite interesting point of this Leipzig Semantic Web Tag. We usually, since the last years, we are also invited students from different University of Applied Science in Germany to the Leipzig Semantic Web Tag to present current work of from lectures or from that is it's coming from some teaching fields in the studies, and this year we have two groups here. One is from the TH Brandenburg, Technische Hochschule Brandenburg, and the other one is from the HTWK Leipzig, Hochschule Technik, Wirtschaft und Kultur here in Leipzig. And the students provided posters. We are still in the Wandelhalle here. And before we go into the break, we want to present in short minutes, like the posters that you can easily vote afterwards, then the posters when you drink your coffee, and so on. Before we will start, I just want to present the two universities. The first one is University of Applied Science in Brandenburg. You already met Vera Meister. She's from this university with a module with master students. And just some facts. So I have a little bit. I have no picture here. So I have to look. So we have 3 faculties and about 3,000 students in Brandenburg. And the other is HTWK. It's a little bit bigger with 6,000 students and 6 faculties at this university. For the ones from Leipzig, I just added the address, so I think everybody here knows HTWK is located in Konnewitz at Karl-Liebknecht-Straße. And also, if you're interested, we have the websites here to have a closer look to the facts. So the first, then we have presentation from 2 models. The one from Brandenburg is in the master degree, and we have 1 poster from 3 students. Unfortunately, only one of the students could be here. The other 2 haven't been able to travel because of illness, and then we have so there's 1 poster from Brandenburg, and then we have another 11 posters from Leipzig. The Leipzig posters are from a module in a bachelor degree, and they present not the final state of the work. It's like a milestone in the project. It's nearly so the final. The final of the project is end of August, so it's half on the way, and the students are also happy to get some feedback if you will be in discussion within the posters. So then the students from Brandenburg provided a video. I will a little bit change. I can try to start the video now. I hope that the audio is working. Then we will start with this video, and afterwards I like to ask the students from Leipzig coming here and saying something 1 minute for each slide to your poster. So meanwhile, I start loading the video. Probably you can come in front. Maybe you can also queue in the as we have the slides prepared. So I have to check. Sorry. Ich muss noch Audio einschalten.
Uns eine Podcast-Folge zu hören. Wenn man mit dem ICE von Berlin nach Leipzig fährt, braucht man circa 1,5 Stunden. Das ist die perfekte Zeit für uns, eine Podcast-Folge zu hören. Da gehören wir nämlich zu ungefähr 10 Millionen aktiven Podcast-Hörern in ganz Deutschland. Ungefähr die Hälfte davon nutzt dafür sogar Spotify. Nur warum ist es oft so schwer, etwas Passendes bei Spotify zu finden?
Diese Frage haben wir uns in den letzten Wochen gestellt und sind dem natürlich auch auf den Grund gegangen. Wir haben die Spotify-API durchsucht und diese bietet keine Infos über Genres, was ja die Essenz von Podcasts darstellt. Also haben wir uns auf die Suche begeben und siehe da, Spotify greift auf den Dinosaurier des Semantic Webs zu, den RSS-Feed.
Wenn Sie mehr zu unserem Projekt wissen wollen oder eine gute Podcast-Empfehlung brauchen, besuchen Sie uns gerne an unserem Poster, der Umwelt zuliebe farblich invertiert.
Also ein Student ist da, der dann auch das Poster entsprechend.
So thank you, and then we will switch back to the slides. So just some words to the language. So the posters, I think, mainly prepared in German. Also the minutes are prepared in German. Maybe some of the students want to also speak in English. And of course, during the discussion on the poster, both languages are possible, so English and German. So I will go in the back, and I will have a look on the time that we do not exceed the 1 minute. First I have to skip the slides from the Spotify presentation, and then we can start.
No.
I have also to say that there's no slides on the screen on my notebook, so the students have to observe the screen.
Hello, we made a website called Learn Sparkle, with which you should not only be able to learn how to create Sparkle queries, but also build on advanced skills. It is divided in 3 subsections. We have a cheat sheet area, a query area, and a tutorial area. In the cheat sheet area, I think you all know what a cheat sheet is. You can see how you can create a query, and you can look for specific elements if you that you're missing for your query. In the tutorial area, we have different levels and different exercises where you have to create a query which has a specific specification. And in the query area, you can just use it as a sandbox and try out different queries. And we've planned to create our own endpoint in the future. Thank you, and if you want to talk to us, come to our poster.
Hello. I found an interesting data set about the booking data of museums in Hamburg. And I was trying to find some sort of indication for a correlation between the weather and the amount of visitors in the specific museum of the Hamburger Kunsthalle. And on my poster there's also a diagram where I plotted the average temperature in just the weather and the amount of visitors, and one can see that I unfortunately, I'm not going to spoil that. If you want to know what happened or what my result was, you'll have to come and look at my poster and ask me that further questions.
Hello, mein Project is the Sparkle for Dummies project. In this project, this project should help people who start with Sparkle to easily create Sparkle queries. You may see it in the one picture. you have one site and there you can pick some components and drag and drop them in the other site, and then you can easily create your SPARQL query. This is just a prototype for now with some components, with the most basic components, but in the future there are some more components planned, and the integration of some other project like the Learn SPARQL project that we have heard earlier, or the SPARQL as Sparkly project to format the output. And that's it. Thank you.
Hello, we're Sparkly, and when we took a look at MDM projects, we saw that there's a lack of pretty print options for JavaScript, so we thought we implement that for ourselves. So basically, the project has 3 core functions, which Paul will explain.
Yeah, so the idea is basically, when we looked it up, SPARQL packages in NPM, there were like a lot of outdated options. The first option was actually 10 years old. And the idea is we wanted to implement a lightweight library, which is only 300 lines of code, and it can pretty print SPARQL queries, and it even has a basic function to pass SPARQL queries if their syntax is correct or incorrect, basically. So there is an option to pass SPARQL in JavaScript, basically. Thank you for listening. If you want to start a discussion, you can meet us outside at our poster afterwards. Yeah.
Also find the GitHub link there.
Good morning, ladies and gentlemen. My name is Lea Kunz, and the topic of my research was if the music genres and from the artist and the Billboard charts, in the top 10 of the Billboard charts in the years from 2010 to 2019, correlate with the music genres which can be found in the most successful music concerts from 2010 to 2019. So basically, I wanted to see if the popularity of the music genres and the Billboard charts correlate to the music which is popular in the concerts. And I found very interesting data sources, like I had the API where I can look for the genres of the music artists, and I could find information about the Billboard charts and tours, basically. And yeah, unfortunately there's no correlation. So like in the charts, the pop is very successful, and in the music concerts it's rock. But yeah, it was an interesting topic. I had fun with researching, and if you have questions, you can meet me outside later.
Good morning. So my project focused on the Catalog of Life, which is an online database of all known species. And it was about making this more available to semantic web technologies by first parsing the whole information contained in the catalog to an RDF format, and possibly later on hosted as a SPARQL endpoint or as a triple store, and further on to enrich the catalog data and the original attributes with additional attributes, and using our rules and semantics to further specify and make it more usable and machine readable. That's the project. Thank you.
Yes, hi. Our project is about the German National Library. We are both students of library Bibliotheksinformatik. So we looked at their offers of linked data and what it has to offer. There is one is the title data from their catalog, which is more than 40 million titles. And the other most interesting part is the GND, the gemeinsame Normdatei, which is actually a combination of different areas or different old data sets. There are standardized persons related to media. There is geographic places. There's an ontology of tags like content description topics. And so we had a theoretical look how they are related to other data sets. They offer all their data in RDF, so it's related to other libraries around the world and other ontologies. And in practical, we try to somehow, there's no Sparkle endpoint, so we try to deal with the huge amounts of data, which was not very easy. And yeah, we have some first example queries, which you can do just on the person data, for example, combined with the geographical data to find out in which cities are the most authors and other people born, or where are they from, things like that. But it would be more interesting to combine it with the title data or other data sets, where you could make, I think, good use of this a huge amount of data. Thank you.
We're Jonas and Tobias, and we programmed a web app searching for flights on the next day using some APIs and also one Sparkle query. And we used that to give flights for a short trip based on weather data.
Yeah, to get the data we fetch from 3 APIs, or REST APIs. One is self-developed with Python. The other one is the Open Weather API, and then we fetch from not very good flight data API and link the data together and to suggest a flight. Yeah, if you have some questions, you can ask them at our poster. Yeah, thank you. Thank you.
That's me. I'm a gamer, and so my question is also about games. I want to find out, is there a relation between the age rating of a game, the genre, and the difficulty? And for this task, I want to ask 3 databases. First, the German Age Rating Agency, USK, Unterhaltungssoftware Selbstkontrolle, the largest video games database on the earth, movie games. There's a great API I can check out. And to be honest, the last website is my own, a collection of tips, tricks, cheats, walkthroughs for games. So I can make an SQL dump or something, and of course I have statistics. Yeah.
So thank you very much, and also sorry for exceeding the session for 3 minutes. Just want to mention, or probably you wonder what are the 2 dots on the tickets are. So the green one you can put on the poster you think that's the best semantic web poster, and the red one is that what you think is the best or has the best design. And I also want to mention that we have then 2 awards, the Semantic Web Award and the Design Award, sponsored by Essenza. And the award winning session is then at 4 p.m. in the afternoon. Have a nice coffee break, and the students want to see you at the posters. Thank you.
little bit more organized according to the linked data lifecycle, and we will start now with a session called Data Acquisition and Sovereignty. And we have in this session 4 calls, 2 from economies and 2 from research. And we will start our first talk with Matthias Kindermann from DATEV. And maybe you will say some words about yourself, and yeah, it's your stage.
Thank you. Thank you for having me. My name is Matthias Kindermann. I'm a senior software architect working at DATEV. I'm not a researcher, but a practitioner with about 20 years of experience building software and software architectures. At DATEV, I'm working on topics like data economies, data ecosystems, and the technology strategy. That's why data sovereignty plays an important role for us. DATEV itself is a cooperative of tax consultants, auditors, lawyers, as well as their customers to provide IT services and software services. We have about 26 locations in Germany, and last year we made a revenue of about 1.2 billion euros. So we are one of the biggest IT service providers in Germany. In this presentation, I want to talk about sovereignty in digital ecosystems using Solid technology, as well as the project Mandat, which uses Solid to create the foundation for a trustful data economy. First, I want to give some background information on what Solid is all about. In 1989, Tim Berners-Lee created the World Wide Web, and today, nearly 35 years later, slightly more than half of the world is using it. The web has produced a lot of benefits for our world. Digital services became the backbone of our cultural life, and today we exist in a world dominated by cloud platforms, social networks, and ecosystems. Sir Tim Berners-Lee believes that they manipulate people with targeted advertising, with political messages, and subtly change people doing things which are not in their best interest. He also believes that the root of the problem lies in a lack of data privacy and lack of user control in social platforms. So to address these challenges highlighted by Tim Berners-Lee, he initiated a program to overcome the problems with them. Since the initiation of the project, many companies all over the world, like DATEV, but also universities and other individuals, are working with Solid and try to enhance the standards around it. Solid itself is built on ethical principles, and it wants to give end users back the control of their own data. They also want to reduce login effects with social platforms and ecosystems. The foundation of today's ecosystems is data sharing between companies, within company and other actors. And today's applications, digital services and processes all rely and are based on data. So the idea is that with trustful and standardized data sharing mechanisms, many processes can be implemented much more efficiently. So together with the Friedrich-Alexander University Erlangen-Nürnberg, the Karlsruhe Institute for Technology, and DATEV, we are working together on today's problems within these data economies using the project Mandat. So what are the problems today? Today's digital ecosystems typically not provide data sovereignty to the data givers. So when you share data, you typically lose control over the data. Once they pass the API, they are away, anybody can do whatever they want. So trustful and legally compliant data sharing is not an easy task. The goal of Mandat is to fundamentally change the way data sharing works. So if you look at on the right, a traditional architecture, you are the user and you access your data using an application, be it Twitter, be it any business application or Instagram or whatever. When you're using multiple applications, there are possibly multiple copies of your data. With Mandat, Solid fundamentally tries to change this. They decouple identity, data, and applications. And instead of accessing your data through an application, you have called a pod, and where you can store your data, and you authorize one or multiple applications to use that data. On the Mandat project, we are working on extensions to the Solid technology for the business context. So working with data trustees, we want to do We want to flexibly implement business processes in the enterprise context. Yes, all with portability in mind, interoperability in mind, data residency, data sovereignty. So let's have a look at a sample use case, the credit assessment for Acme Corporation. Acme Corp persists its data in a solid pod. POD stands for Personal Online Data Store. You can think of it as a personal web server. Acme can run the server on its own hardware. You can also use a pod provider, an open and free pod provider, a commercial one. For this use case, because we have sensitive data here, Acme runs the pod on its own hardware, their own behind the desk or whatever. The pod can be accessed using standard mechanisms. There's a W3C standard, the solid protocol, which defines the semantic together with the linked data platform to access, to create, read, update, delete semantic RDF data. Different actors, once they are authorized, can persist data in the pod, create, read, update, delete. They can read portions of the data or whatever. The data itself is stored in RDF format. So the description framework, a resource description framework, so it's enriched with semantics. It's not just data, you can see it as kind of knowledge graph. Anybody who retrieves data using standard APIs, they can of course make a copy of it. So then the sovereignty is lost. The idea behind solid pod is to not address this case, but you can see the data in the pod as this kind of single source of truth. So there's always one truth, and it's always in the pod. The idea behind these technologies is the standardization, the standardized protocols for create, read, update, delete, the standardization in terms of RDS schema and interoperability support a high degree of optimization, which later supports better process efficiency. That's the idea. When we have more sensitive data here, it's possible to use other technologies like international data spaces or whatever, so we can maybe do not return the data to the financial partners, but instead get their app running on our pod. So we have some kind of computed data. We don't have to return the data to the consumers. We can take their apps and run them on our pod. So the vision of Mandat is to resolve these areas of conflicts where missing data sovereignty turns to problems when building data-driven products. There are at least 3 areas of interest. The first is data residency. I want to be able to decide where my data is physically stored. I want to decide if it should be under my desk, or around the corner, the Rechenzentrum from any local provider or a public cloud provider. The second is sovereign user control. I always want to be able to get access to my data, always be able to see the latest version of my data, always be able to access it, even if the apps which are consuming them are not available. The third one is we want to use well-established standard technologies to integrate identity, application, and data, all based in the end at semantic web standards. In the end, we want to provide a foundation for a trustful cloud-based ecosystem with data sovereignty, portability, interoperability, and data residency in mind. One last word, we are still looking for software developers and software architects to help us building this. So if anybody's interested, don't hesitate to contact me. Thanks.
Thank you, Matthias. Are there some questions? I see 2 questions. I will start here. Seniority. So you reported on this research project. Do you, as DATEV, I assume you have some exploitation plans how to use it internally. Can you explain a little more what are your DATEV goals and where you want to use it later?
Currently, we have not that data goals. We have different things in mind. Currently, there's a small team experimenting with Solid and the technologies. There are things like maybe we can become a pod provider so that anybody who wants to store their personal data in a pod can use our infrastructure, our trustful infrastructure to host them. That is one business opportunity. But also to create, there's a foundation for data-driven ecosystems. If there is more trust in providing data, the users provide more data, and we can do much more with them. This, in turn, can create new opportunities for creating data-driven business models. Yes.
Okay, here's the next question, Andre.
Very nice presentation about something that are quite like new, solid. And you mentioned the word ethics. Like I saw like many people like talk about ethics, but I mean, could you give us a definition about ethics that you are talking about? Like, because we could be like many of confusion here. And I think that this is a kind of important thing to discuss right now. Thank you.
There are many different ways to think about ethics. One way is to look at the W3C standard. There are ethical principles Tim Berners-Lee formalized as a standard. So there's about 10 or 12 rules to not harm the end users, not harm the human mankind, etc. The other thing is most users give away their data because they think they can the value they get is bigger than the value they give the data consumers. But it's kind of the privacy paradoxon. There are many explanations why the user think that it is, but most do not have in mind that you can see information as kind of the carrier wave principle. In 5 or 10 years, you can get much more information out of data than today. So maybe the users don't even know what the future developers or scientists can get out of the data. And this is some kind of cognitive dissonance, cognitive Verzerrung. We have to protect the users so they don't harm themselves. This is one way to look at it.
I saw two further hands. I think Edgar was first, and the second one was Hans-Gert.
Hi, I am Edgar. My question, it's more like a comment. Maybe you can elaborate on that. There are different initiatives that goes towards the same direction of Solid. One of those, it's actually in Germany. It's led by Fraunhofer. I don't know if you heard about the International Data Space, yes, which has also association. And my question is that if you haven't looked into that, or either collaborating to this association with ideas, or either consuming and developing something better, or can you comment on that?
Yeah, sure. International data spaces is kind of a blueprint to allow data sovereignty in data ecosystems. I think Solid and IDS are orthogonal standards. They can complement each other. So my latest news is that the Eclipse database connector, which is foundation for international data spaces, gives a linked data platform integration, so you can dock a Solid pod onto a linked international databases network. They complement each other. IDS is for about, I want to be able to know where is data X or Y located. I don't have to know where it is. I just call a broker and they give it to me. Solid doesn't address these problems, but Solid addresses the problem to give everyone the opportunity to persist their data and make it portable. So these complement each other. And my current vision is working on that to integrate them both, even with Gaia X and more.
Hans-Gert?
One of at your last slide was data residency. Data generators decide where the data is stored. How it is if the data are prepared for a third party? Do you use common data stores that are owned by both of the parties, or how do you cope with the question when the data are produced for a third party?
But the data is consumed by third parties?
Hmm?
I didn't understand everything exactly, but it's a question, how do we handle when a third party consumes the data?
If you produce data for third party, so you submitted the data, the other party uses the data, and there may be later on a dispute about what was the data. So both sides need the data, but the data generator at the one side cannot decide where to store the data on the other side. So I think this statement, the data generator decides where the data is stored, does not work in such a situation.
There are many different perspectives how to look at it. One is the sovereign cloud principles. So you have national guidelines around the cloud, and you can force that the data do not leave them. The other thing is international data spaces. Instead of giving the data away, you can get the application to the data. That's one thing to look at it. So there are options, but it's not easy.
Okay, let's thank you again, Matthias. So, the next talk is given by Nathanael Arndt, and it's the second talk from an economy, from business. And it's about, wait,
da steht's doch.
Building and exploring knowledge graphs with the Essenza corporate memory. Nathanael, it's your stage.
Thank you very much, Michael, for the introduction. So, yeah, hello again. My name is Nathanael Arndt. I'm working as Senior Linked Data Expert with Essenza GmbH. Today I will give you a brief introduction into how to build and explore knowledge graphs with the Essenza corporate memory. Essenza corporate memory is our main tool as a business, as Essenza, which we distribute. And for sure, if there are open questions after this talk, you're invited to take a closer look at the product itself. Essenza as a company is distributed over Europe and also beyond. We have employees, collaborators, in various places in Germany, but also in other countries in Europe and abroad. But our main base is here in Leipzig, in the Heinstraße. And as you can see, we also have a lot of customers from various domains, and you can read names of big companies, which you know already. But now let's look into the way how to build and explore knowledge graphs. If we have perspectives on data, if we look at data, there are various angles from which we can look at the data, and parts of the data are viewed from all of these angles. What we have in a company or also in other organizations, we have various sections who work on different aspects of the things we're looking at. So in a company, for instance, we can have an engineering department, manufacturing department, logistics department, and marketing department. But they all look on the product or on the objects with which they're working from various angles. And so they also store the data about the things they're looking at from their viewpoint, from their angle, in a structure, in a data structure that suits them. And then we end up not with constructing a bigger combined picture of the things we're working with and the things we're looking at, but we construct a lot of silos of the things. I guess you also know the Höhlengleichnis, somehow like that. Now if we look at the web, we have Wikidata and we have DBpedia, which provide a global and unified access to knowledge together with all of the other data sets on the linked open data cloud. But all of these little bubbles in the linked open data cloud, they have their perspective on the data, but they provide it in a way that is interlinked. Today at the keynote, we've heard already things about ontologies and vocabularies, and we also had a lot of questions with this regard. So you see, that's very important in our area, and you know it. So the DBpedia expresses extracts structured content from the Wikipedia and allows us to browse through this data. That actually was, co-invented by one of our co-founders of Essenza, by Sören Auer, when he was still working here in Leipzig in our research group. So now the question is, maybe I should have made it a little bit bigger, what is your corporate DBpedia? What is your corporate knowledge graph of things that you need to interlink and need to know? So you have various sources in various formats, and you extract the knowledge from these fragmented corporate resources, and then we combine them using vocabularies into a knowledge graph. In the end, we have these few angles. We have the IT solution one, maybe car insurance in this case, that searches for, or is interested in various attributes of a car. And then we have the garage car reality, so both of them have different realities and different applications, and they're interested in other attributes. But the real car, the real unified car, has a lot of more attributes. So if we combine them in one car, we have like a digital twin for the reality. I think we have seen this concept also in the previous talks today. And we can work with this as a representative in our data set for the reality. But as we so far work with, or not we, but a lot of companies of our customers have their data in flat formats, in tabular data, and with an ontology, we have the possibility to interlink the schema and provide a common schema for the concepts that are used in this in these tables, and we can even then identify points where we want to interlink or where we are not sure if we should interlink. Like here we have maybe a typo, Kula and Kumar over here, and film company and film company. So should we link them? Now in a combined knowledge graph, we have the possibility to look at this from a common view and solve these problems. With the Essenza corporate memory, we take you on a user journey through various functional areas, which have the raw data as an input on the left, from which we can then build a knowledge graph, which you can explore. And on this knowledge graph, which you can explore, you can perform some data shopping to extract the parts of the knowledge graph you're interested in, to consume the data, and to put it into systems where you want to have them in those formats. So you can also provide new APIs on the data. And yeah, for sure, we also have access control and several APIs to govern the data as well. And which is very helpful, we also have corporate memory control as a CLI tool, which allows us to perform a lot of automation. Well, we also have a lot of automation in here already. So let's look, take a closer look. We have a linking tool that allows us to perform linkings on the data. We even have a linked learner, and based on that, we can interlink the data when we consume the data from the sources, and as a browsing interface, we have the possibility to build customized user interfaces that suit your specific domain or the domain of the people who work with the data. Yeah, that's also data defined with Shackle. I think some of you have heard of Shackle already, and it's very powerful here. So the cycle we are going through, our enterprise knowledge graph project flow, is basically that we first gather the data, gather example data, and documentation for each source and target of the data. Then we create a core semantic model from bottom up, or we search for an existing ontology vocabulary that we can use. We create the mappings of the source data to the data model which we selected, and review this model with our domain experts, or not with our domain experts, but with the domain experts of the customer. And then we further enrich the data and further improve the mapping and linking of the data, and constantly review it with the domain experts. And then we can also explore the data and verify that the data is correct and suits the use case. And we iteratively further expand the model and iterate on this. So that's a technical perspective. Wie viele Minuten habe ich noch? Oh, okay. So I will take you on a short walk through this as a use case of the Data Week web page, where I've also used the Essenza corporate memory tool. Here we have a set of Google spreadsheets on which all of the people involved in the Data Week organization could work, enter the information of the speakers, the organizations, the talks, the individual days. And then with data integration, we performed the linking on this. And then we enhance it with an organization and layout graph, on which we can then apply continuous integration to build our web page and the live page, which you all see on your mobile phones and laptop computers. So this is the view of the Google spreadsheet in our corporate memory tool. So this is the raw data. And here I took as example our keynote speaker line. And then we create a workflow with a lot of individual transformation tasks. And here we look into one of these transformations. So basically what we have to do is take each of the columns and map them to the property of our ontology that we want to use, which we chose already before, which we used all of the years before, and attach like language, tags, and so on, and transform the data. And then we can browse the data. So here we have the individual properties in the graph for Sebastian, and also his short biographical information, which I read this morning. And then we apply the continuous integration on this to consume the data, to get it with the CMMC, with our command line tool, from the graph storage and processes. And here we end up with our integrated data in the web page. So thank you very much for looking at this short example.
Thank you, Nathanael. So we have now time for 2 questions. That was the first hand, and the second one.
A short question. To make you a distinction between data and metadata?
Okay, I have my microphone here. It depends on where you need the distinction. If you need a distinction, sure, we can distinguish between that. But from a data storage perspective, what you refer probably of metadata, we can just store it in the same graph as triples in our RDF graphs, as you usually do it for RDF. So I would say maybe yes, maybe no.
Nice answer.
And in knowledge graphs, there's no hard boundary between data and metadata anymore. So I think the answer is the correct one, so to speak. I would like to, one comment, the fact that you mentioned workflows warms my heart, I have to say. So this is the thing that troubles me most. How can we enhance processes rather than artifacts? This is the right perspective. However, I have a question to this diagram on slide 13, this cycle, how we build knowledge graphs. My experience is that this is outdated. This is not the present anymore. This is the situation 10 years ago. Today, we don't have time for this anymore. Small samples, and we have these nice chats with these experts, and it sounds so good, right? But it doesn't work like that. My impression is you start with very large amounts of data, and then you start with very ugly constructs around it. So you push the complexity into everything that deals with your bad knowledge graph, and then over time, you push the complexity out of the queries and out of all the handling into a better graph model. I would just like to hear your view on this. You have access to more industries, I guess, what they say.
Okay, so actually I'm in the company since December. I've gathered some experience with that already, and actually what you describe, I think describes very well with what I struggle at the moment. Sure, we have huge knowledge graphs, and I think what answers best is to organize the ontology engineering workflow parallel to the data engineering workflow, and to have a proper maintenance of your ontology while it evolves and while the data evolves. And there we also come, I think, somehow to parts of the aspect of the temporal knowledge graphs which we had. So as we know it from software engineering, we always have also the artifacts which are built around software also evolve while the software evolves. And usually we do some version control on that and work on these artifacts, and so we need to, I think, do similar things on the knowledge graphs and the ontology in parallel, and parallelize the process and allow these steps to be performed in parallel. So maybe there are a lot of, there are the numbers which give a very clear sequence in this cycle, but I think parallelization of the processes is the answer, basically. Or not, maybe not the answer, maybe I'm too young to tell answers, but the way I would try to go.
Thank you, Nathanael. So, I would say, let's thank you again. And
Is das der nächste?
So that means we had now a talk about sovereignty, about creation and exploration, and now we come to a talk about data acquisition, given by Roy Meissner, and it's about a recently started project called AKSW Datenbeschaffungs-API. Roy, it's your stage.
Thank you very much. So, as Misha introduced, my name is Roy Meissner. I'm a semantic data lifecycle scientist employed at Infi, which is one of the two partners of the project. The other partner is a company called ScaDS.AI, and the project is about, for the German term, eine AKSW Datenbeschaffungs-API, or for the English term, it would be an Arrakis data acquisition API. The main goal of the project is to optimize the retrieval and integration of AKSW data. And the main obstacle is that the AKSW data is spread over the various federal states of Germany, so it's focused on Germany as a project. And just in case you don't know the term AKSW, AKSW is an abbreviation for the German term Amtliches Liegenschaftskataster-Informationssystem. It's quite a complex term. There is also an English correspondent for this one, but the main content of these information systems is data about federal and private properties, so about buildings, about streets, about forests, and so on. And these are usually represented to users in the form of a map. They can click through. There is a high level of detail in these maps, and they are used for different use cases I will present later. We want to develop an AKSW data retrieval and acquisition API, which basically provides metadata of AKSW data and also of AKSW-related products to the various metadata portals, and also an API enabling the ordering and integration of AKSW data from third-party systems. So maybe some of you might know the QGIS system, which is widely used. So we want to integrate it there so you can order and retrieve the data right from the QGIS system. Just to give you a quick overview of the two partners, as I said, there's a company which is called ScaDS.AI. The company was founded in 1982 and its headquarters is in Sinzig am Rhein. It currently got 37 employees, so it's kind of a small company, and it handles all kinds of geodata. So it basically acquires, processes, provides, and researches geodata, where AKSW data is one part of these geodata they handle. They developed their own shop system, which is basically a kind of distribution channel spanning several federal states of Germany. Currently, at least for the automatic part, 7 of the federal states from the 16 federal states are integrated into this shop system in an automatic way. The others are integrated in a manual way, and they provide via this shop a centralized interaction system where you can get various geo and also AKSW data in a file-based manner. So you basically, or you can imagine you got a map in front of you, and so you can draw a polygon on this map. And so with this polygon, you select a special part of this map. You can select the data format you want to receive your data in, and also the reference coordinate system you want to get, which is kind of a specialty for geodata because in different data formats there exist different reference coordinate systems, which you need to map onto each other. And of course, it's a shop system. It provides payment and accounting functions. The company SIS developed their own data translation system called a Citra key. So they are able to transform various data formats, various reference coordinate system into each other, and provide a wide variety of solutions to users. I guess most of you know the INFI. It's an association, and I just briefly go over it. It's been founded in 2006. The headquarters is here in Leipzig. It's actually nearby. INFI currently employs about 160 people and got 20 associated professors. It got 3 competency centers, or you could also say 4, because there's also ScaDS.AI, which is an associated competence center, and they also got their own stand outside in the Wandelhalle. So if you're interested, you can directly go there. INFI basically handles all the different topics of the semantic web, researches these topics, and also tries to transfer their knowledge and to develop technologies into the market and into companies. Back to the project. There was a study called BUB study where the ScaDS.AI participated, which basically researched various topics for geodata. AKSW data was one of these topics, and they found a few things. So AKSW data is a basis for various actions and decision processes in Germany. It's used by the federal state of Germany, but also by the single federal states, but also by companies and other players in the market. And it's used for example, infrastructure planning. It's used by the service industry. It's used by bigger companies like the car manufacturers. and also for the interstate topic of mobility, movement, and change. But the main problem is that we got this federal system in Germany, which is kind of a good system, but it also has its drawbacks because all of the federal states develop their own solutions and develop, for example, also for AKSW data, their own data formats, and they use various data coordinate reference systems. And only a few of these already provide their data as free and open data on the internet via geodata portals. Currently, these are 7 of the 16 federal states. The others provide these data on manual ways, so you need to go to the ministry and ask for the data or request the data. And as I said, there are a few differences in the data you can get from different federal states. So, for example, in the data model, in the currency of the data, so for example, Hessen updates their data on a monthly basis. North Rhine-Westphalia only on once half a year, and they provide different formats. So as a user of these of such AKSW data, you are faced with a few obstacles. The first one is the findability of data. So you need to research for data in different sites. You need to find the right person to speak to, find the right portal to get the data. And in case you got all the data you need to integrate it in order to use this data in your system you're using. So for example, a QGIS. Inside Ada, as I said, we want to improve on the situation, and we got a splitting of responsibilities. So SysTDI as a company, they want to develop and extend their portal technology in order to provide metadata via open metadata portals. They also want to develop an exchange, a communication channel, a data exchange channel between various geodata portals. So there are various players in the market and also the 16 federal states, and they want to provide a way to easily exchange data between them. Of course, they are a company, they want to implement their ordering APIs, so they can use the data from third-party systems, and as a proof of concept, they want to create a QGIS plugin integrating all of the developments. We from Infi, we want to provide a semantification of the various AKSW products out there, contribute to architecture drafts, and also support in development of interfaces. Our current plan is to split these into 2 phases. We want to create metadata for the already existing data products. So basically the upper half part of the picture is already existent. So the various data sources from the federal states, they are drawn together into the SYS database and provided into different formats via the Citra key technology. And we want to extract existing metadata and also create new metadata from these AKSW data and process these data via a recently published project called OntoFlow. It's a pipeline flow processing technology for ontologies, and want to get semantic descriptions of the different products. By the semantic descriptions, we want to stick to various standards. So I guess the DKIT standard is widely known, at least for metadata portals. And a bit newer, there is also the DKIT application profiles standard. Interestingly, there's there are also special standards for the single countries in the EU. So there's also a DKIT application profile for Germany, which we want to stick to, and also 2 standards in the geo corners. So there's a quite new standard, GeoDKIT AP, and also the Inspire guideline from, I think, 2009. And with these created metadata files, we want to harvest them from a company metadata portal, which provides them open and freely accessible, which is again harvested by various government or federal state data portals or other company data portals like the mCloud portal. From a user kind of perspective, There will be the QGIS plugin, which is an integrated proof of concept for the whole findability, availability, reusability, and interoperability. So via the QGIS plugin, you can search various metadata portals like the mCloud portal, find data you are interested in. The plugin will automatically contact the metadata portal of the company in order to make sure the data is available, it's up to date, it's the latest data they got. As it sticks to various standards in the metadata portal market, the data will be reusable. At least we hope to improve on usability by these standards. And via the Citra key technology, the data is interoperable, as you can request it in various ways. And all of this is implemented in this QGIS plugin, which is a major step up in comparison to what you currently need to do, as you need to basically find all the data yourself, transform all the data yourself, and then use this transformed data into, for example, QGIS. As I'm running out of time, I will skip the next 2 slides. So if you're interested in this topic, I wrote you a few links here. So we got a recently published project website. The project is running for about half a year now. You can visit. You can also find some news about the company and also the project at LinkedIn and Twitter. If you're more interested into this topic, there's also a newsletter on the website you can subscribe to, or also receive project updates via the mFund newsletter. And we plan to be represented at the FOSCIS, so the Free and Open Source Geoinformation Systems Conference in 2023.
Thank you, Roy. Are there any questions from the audience? Don't see questions? So, here.
I want to know more about the OntoFlow pipeline. What is that?
Well, it's a recently published project. It's also been developed at INFI by Gordian Sivas. I think it was published 2 months ago in Greece. It's basically a pipeline building on the Nextflow technology, which is used in bioinformatics, and was extended by various tools to handle ontologies in semantic web, and ontology creation workflow, ontology update workflows, and so on. And for example, an output of this pipeline, an exemplary output of this pipeline is an ontology documentation website where you can also browse the ontology and have a standard documentation for it. Well, I guess if you're a researcher, you can have access to the research paper about it.
I wasn't in Greece, I didn't apply that, so that seems like a business.
Right. Are there further questions? Andre.
Since you mentioned research paper, how many researchers are actually working on this, and they are masters, PhD students, postdoc, or whatever? Can you answer this in numbers? Simple.
On the ADA project?
Yes.
Well, it's a rather small project. As I said, it's a small company, so I think there are 6 people working at the company and 1 person working at INFI, so that's me. I'm a PhD student and doing research for the project and the project topics. I'm not quite sure about the company. Maybe you know a bit more?
How much students they have, or what do you mean?
Well, how much researchers they got?
There are a few ones, but I would say maybe 5, 6, possibly. Yeah, something like that. Yeah, it's a small project, but you're working on the integration of the federal states of Germany, so I think the impact could be quite massive. Possibly, we would, yeah, we will see. So, thank you again, Roy. So our next talk, our last but not least talk in this session is given by Sebastian Hellmann, and it's not about a technology from 1999 or a technology from 2022. It's about a technology which is much more visioned. So it's about the LinkMaster 3000.
Yeah, it's clearly an improvement over the LinkMaster 2000.
I know.
Okay, yes. So my name is Sebastian Hellmann. I would, no, not yet. Very good. So my name is Sebastian Hellmann, and I would like to introduce the LinkMaster 3000. If it's not linked, does it even exist? First of all, I would like to talk about small data and explain what it is and why you need it. So, in truth, nobody really needs all the data all the time. And then small data is exactly about this. It's about the right data at the right time when you need it. So if you compare this to big data has a significant collection delay. So big data has a big delay because by the time you collected all the data and integrated it, it won't be up to date anymore. Small data can be actually up to date because for small data, there is a small delay as well. And there are literally an infinite number of small data use cases. So what does it mean? Every human needs a tiny bits of contextual information on a couple of occasions each day. So you want a phone number, then you go to the supermarket, you want to know where the food comes from, you want to know about COVID. Tonight you're going to wonder whether there will be more Stranger Things episodes, for example, or maybe you're looking for free apartments close to bilingual kindergartens. Yeah, the good news here is that this small data is already plenty available, and I'm going to show that, demonstrate this on the next slide. So Nathanael already introduced DBpedia a bit. So what does DBpedia do? Since 14 years, we extract information from Wikipedia. The main knowledge graph we produce is the, can you see the mouse pointer? Yeah, is this one. So this is the DBpedia snapshot. This is just the English portion of the Wikipedia transformed into a knowledge graph and published via linked data. And then we talked to our members and they asked us, well, can't you make it bigger and more domain specific? And then we said, yes, we can. So we used the data bus for this, which was kind of like our automated tool for fusion and knowledge graph building. So first thing, we made a Dutch national knowledge graph fusing extra data from it, from the lot cloud. Then they asked us, can you make it even bigger? And I said, yes, we can. So we made it much more bigger. We called this the small diamond here. It's a fusion from Wikidata and all the Wikipedia language versions. And then they asked us, yeah, but can you make it even bigger? And then we said we can, and we made it even bigger, like a very huge knowledge graph, very rich. And then they said, well, now it's too big, it's very hard to handle, we need to download it, and it's very slow to update and things like that. So then we kind of like re-engineering this fusion pipeline and linking pipeline into the LinkMaster 3000 using a small data pattern now. As a comparison on the log scale, so these are the biggest commercial knowledge graphs here, Google knowledge graph and the Diffbot knowledge graph. But if you compare this to the data available actually in the linked open data cloud, which is of course only estimated, this is several magnitudes larger than what Google claims or what Diffbot claims to have. And if we talk about linked open data, we talk about the lot cloud and then also about schema.org, which is also a really great source of knowledge, of data on the web. Let's reiterate the linked data principles a bit. So these were provider or publisher guidelines given by Tim Berners-Lee a decade or 2 decades ago. So the first 3 tells you that you should use URIs to name things, use HTTP URIs so that you can look up those names, and then when they resolve, then you should provide useful information. And the 4th rule is about including links to other URIs so the users can discover more links. So these principles actually result in the largest and constantly updating knowledge graph on Earth. Yeah, no comparison possible with all the smaller graphs. In fact, it's a distributed database. You could consider it a key value store. So the keys are the resolvable URIs. Anyone can extend it. And it's also extremely fast if you cache it properly. Yeah? So there are network, server, and client-side caching, same as with web content. Now let's talk about the fourth rule. So include links to other URIs, and these are provider guidelines. If you can retrieve links from somewhere, they have extremely high value for data consumers. So there's a high need to get these links. But the creation and the maintenance relies on the provider, actually. And they have kind of like low incentives to do a lot of linking because they're already publishing their data. So the system kind of like a I would call it sub-optimal. Yeah. And where we are going to extend this is kind of like make a rule 4B. You can use the Link Master 3000 to create, maintain, and retrieve links to other URIs. So like a third-party offering that just gives you more links and allows you to curate them. So now I'm going to go more into small data. So I'm going to present a real-world small data use case. At Inphi, we had the task to create a publication list for all our 100 or 150 researchers. I don't know, Roy had a different number, for our website, inphi.org. Yeah? So what was the proposed solution by the Inphi website team? Well, we set up a Git or a Wikibase, and then all researchers just copy their publications into it, and whenever somebody publishes it, well, they just need to have to update it. And of course, all the researchers were not so happy about the extra micro tasks spread here. So I would like to present the Link Master 3000 approach. So every researcher at Inphi gets an Inphi URI, and we load this Inphi URI into the Link Master 3000. Then for each researcher URI, we find exactly one link. It's called we call it a master link to one major publication service, and there are many of them. Then we use the link inference engine to find all URIs and discover new links, the global LD API, we call this. And we use all those links to retrieve the publication data on the fly and cache it, and it updates frequently, and nobody has any work. So now I'm going to show you some of the Link Master 3000 tools. There are actually three tools involved. So this is the pre-launch announcement here, and the real launch date is then September 12th at Semantics. So first is the global LD API, which gives you link inference. You can look up more links. Then the global LD browser. This is where an HTML interface which resolves all links for you and then gets all the data via link data and shows you all this data. And then there's the Link Master 3000 itself, which is the open online link curation platform. And I'm going to talk about utility of this platform for link data providers and utility for link data consumers. Okay, so the global LD API, what do? We just have a lot of links collected, and we pre-compute same as clusters for core namespaces. So you can look up more links. So here's an example. It's an identifier, a URI from the German National Library using the GND. So this is Leipzig. And if you retrieve it, resolve it, you get 3 same as links. Now, if you take this identifier and put it in our API, you will get a total of 118 links. So you will get more links and also a larger variety of links, because you will get links to DBpedia, geonames, music brands, and many more things. So you can continue discovering. The global LD browser, so this is an HTML interface that will do the resolution in the background. So you can take the same identifier also and access it. I have it preloaded here. Yeah, so this is Leipzig. Of course, there are always some clustering mistakes. But here you can see that the data is retrieved from 118 sources, and you get around 8,000 triples. I'm not sure if this number is correct. As I said, it's just a prototype. But you can really directly compare the individual values. We did some schema normalization between the data sets and the different sources. Yeah? So here are all the sources given. Let's continue. Yeah, so now let's talk about the Link Master 3000, and I'm going to start with the link data providers. So it's basically useful for all sizes of link data providers, whether you have very large or very small offerings also schema.org. It increases inlinks. That means we spread your URIs if you're in the system and also link back from DBpedia, and others can also download the links and link back to you. So there you have a kind of like a benefit as provider. And then there are certain to-dos, however, that you need to do as a provider. Yeah, so first of all, you need to guarantee technical functionality of your linked data. So this is either hash or 303 redirect or schema.org. We provide debug tools for this, which are directly on the website. So I'm going to show you the current interface. So here's the launch countdown on the top. And then you can see how many entities are already indexed. So we have this from the Fusion project. And also we started to creating namespaces here. So maybe look at the DBpedia namespace. You can see that we clustered the entities by classes. And then we're tracking the links, the link state here. So you can see that around 70% of all persons are linked. There are download links where you can download entity URLs and the links. You can update entities. It just suggests you open tasks where there are problems and you can add more links. So it's kind of like a guided linking system. And then it also takes sampling of the URIs and you can, okay, interesting. Oh, no, now it works, okay. So this is the network here. It gives you, it samples your URIs and tells you whether there are any technical problems. For example, if you go to Wikidata, they allow it actually, but I think they have a glitch here, so they currently have cores not enabled in some redirect, but I'm sure they will fix it now that we display it here. So you can kind of like debug your own database and make it better. Right, so the first task was guarantee technical functionality. The second task is that you regular upload all your URIs, kind of like a semantic sitemap. We keep this, we spread it for you. I already showed the Manage Entities button. And then the third task, this is the most important task for the linked data provider, you should relax. Because you can actually let the users and the data consumers do the links, because they have the highest interest in doing this. So in the end, Linked Master 3000 is especially built for consumers, so that they can make the links there online, download them, use them. Yeah? And what the linked data provider can do here, so besides relaxing, is then go to the Linked Master 3000 and pick the links up periodically and include them in their own databases, yeah, to fulfill Rule 4. Now let's talk about the data consumers, why they would even use such a thing. So there are certain data consumer challenges. Yeah? So I just listed 3 here. I think all the other people at this conference already talked about the challenges. Yeah? But generally, so you have some sort of integration project and you started, and the first question is, where is the data? Where do I get data from? I need data about this. Where do I get it from? Yeah? So this is kind of like a thing. So you need, ideally, you need the URI or the data sources and everything. It's very hard to find, actually. After download, you start the integration process and you do local linking and deduplication for integration. That means you have a copy of all the data and locally you run some linking engine, and this is normally done one time. And very often you only get 60 to 80% F measure. Maybe if you're Professor Rahm, you get 90%. Yeah, but normally this number is very low. And then the question is, how do you improve this? Yeah, and so there's no solution to it really, or not so good tools. And then next month, if you re-download all the data, are you going to link again? Yeah, and then are you keeping the old results, or things change? So you have also co-evolution problems. So what does the Linked Master 3000 do? So it's an online platform. It helps you with an agile continuous integration process. So it's not one-time linking, but it's iterative and it can be improved over time. So I put the sign here, how to link correctly. Yeah, so there's a right way and a wrong way. And so it's not about really the hard results, but more about the methodology to create and improve the links over time. The other good thing is you can reuse and share the linking effort with other consumers, because many people can work on the same, linking the same namespace. Then it's an open platform with services on top. So what does it mean, open platform? You can export plain links. That means you can return your work. So everything the community puts in, they can get out again. Yeah. But you have to pay for inferred links and convenience. So basically, we are building the inference clusters, building the API, hosting it. So that is kind of like a service on top. And then there are also on-premise solutions. Yeah, so there's a full stack of link curation tools also planned. And, but I'm not going to talk in detail about this. These will be available in September. And I would like to thank all DBpedia members, especially the ones which contributed to the development of Linkmaster 3000. And thank you. And just a reminder, tomorrow is the first DBpedia Knowledge Engineering PhD Symposium.
Thank you, Sebastian. Who in this room is consuming data sometimes? Lift your hands. Are you relaxed now?
No, the provider.
You said the consumers can be relaxed.
No, the provider.
Who is providing data in this room?
Yeah.
Okay.
So because you have less work doing the links.
Okay. Are there any questions here? So we have a few minutes left for questions. I don't see questions. Awesome. So that means you... there, sorry. Kurz.
Why not Linkmaster 9000?
Yeah, as I said, we started with Linkmaster 2000, but it sounded too antiquated. Yeah, you can have many associations, I guess.
Okay, nice. So, for me, everything is clear. So, where's? Okay, now the hands are raising. Who was first? Frank?
Hi, thanks for the talk. And just a quick question on, so when the provider has relaxed and pulls in the data which were created, so how to ensure the quality? So is there any thoughts on that or anything to support that? What the users did when they created links? That would be my question.
Yeah, the quality is maintained online. So you have you can directly see what is the quality here, right? So this whole stack of link curation tools, this is online. So basically what you do, you outsource the life cycle of link creation to the Linkmaster 3000. Yeah, so at the moment, people maintain it internally, so the provider is responsible for the data quality and the hosting and many tasks, actually. And then additionally, they get a lot of user questions. Yeah, why can't you link to this? Why can't you link to this? Yeah, don't you have links to I don't know what? Yeah. And this is actually, we also have these questions, yeah, all the time, and this is very annoying. But now the consumers can make the links directly there, so you can tell them, yeah, go there. Whatever you create there, we will include it next month. So that is the idea.
Thank you. It's not a question, a small suggestion. May you please open the LM3K? Yes. I would prefer if there were delimiters for the thousands, so it would be more readable. It's impressive.
Yeah. No, this is not impressive. This is so we had more. We have been running these indexes for a while because of the building the large knowledge graphs. Yes, we maintained like a much larger index. Now we went back down, and because we wanted it a little bit cleaner for the start now. Yeah, a little bit more structured. So it's like, it's really...
Okay, I understand. But nevertheless, this is something what you want to tell your customers or your readers or things like that, and it's better readable if you have this point.
Yeah, definitely.
Only small suggestions.
It is also not so you can go there. It's DBpedia link LM3K. The thing is, most of the buttons still do not work. So we are see you have the timer, and there's also a roadmap. So the debugging works already.
Great. Further questions? Maybe one question could be answered. No? That means let's thank you again, Sebastian. You were the last talk. Now it's time for lunch. And as I recognized correctly, we see us again in 1 hour, almost. Okay. And during the lunch, there is this poster session as well. So please go to the posters, have a look there, vote. Don't forget to vote. And we see us again. Thank you.
There's light in your mouth.
2, I think. I would propose that we start, even if some of the participants noch in the break. So hopefully it will not so much disturb during the talks. And yeah, now we have a session on collaboration and ontologies with 4 talks. I hope all of the speakers will apologize if I keep strict signs on the time, as we have now 2 sessions, so between a small 15 minutes break between the sessions, so we should not overdo then the talks. We have 4 talks now, and we start with Fawad Khan. He is a scientific programmer at the Technische Informationsbibliothek in Hannover, with the talk on collaborative and across-stakeholder ontology engineering.
Good afternoon, everyone. My name is Fawad Khan, and I'm a software engineer at TIB. Today I will be presenting about the collaborative and cross-stakeholder ontology engineering platform that I'm working on. I will also briefly discuss about the research background from Veteles Wiens, which we have incorporated in our approach to develop this platform. These are the topics that I will go through: motivation and for the project, and then there is mapping pipeline, collaboration, a resource relation model, visualization, and finally evaluation approach and evaluation results for our platform. SC3 is the name of our project. It stands for Semantically Connected Semiconductor Supply Chains. It's a European Commission funded project, and the running time is until September next year. Currently we have already released first MVP, and we have conducted our initial user survey, so I'm going to present about that later in the slides. So the motivation for this project is that semiconductor production is a complex industry, and supply chains are complicated by short product cycles and strong dependencies to further industries. We need a stable generic industrial reference communication platform. So the aim of this SC3 project is to develop such a platform for various stakeholders to come together on this platform and collaborate and to present different visualization to different expert groups. So the challenge is to bring the domain experts and knowledge engineers on this platform and to develop common understanding of the domain and its formal representation. So our objective is to provide this platform to provide different visualization. In our platform, we have identified 3 different user groups, so novice, intermediate, and expert groups. And we aimed in our platform that they can all work together on developing ontologies using this platform. We are in our platform, we are using a pipeline-based approach. The benefit of this approach is that any data source, because ontologies can come from a different data source and different types. So for example, it can come from OWF, OWL, or TTL, and it can come from various sources. So we want to create a flexible pipeline where we can plug in different data sources, and we can also plug in different visualization, visual representations. So at the first step in this pipeline is the data processing layer. So it converts whatever the data source is into model, which we call resource relation model. This resource relation model is then used as a core for different visualization methods. So this, for example, for the graph visualization, we convert this resource relation model to a vertex edge model, and then it is further enhanced through merge, split, and nesting mappings to a node link model, which can then be visualized. Here is the diagrammatic view of the pipeline. So at the start, we have data access handler, which converts any data source into a JSON structure, and then it is parsed into a resource relation model. This model is then used for different visual representation. For example, here again we are showing it for a graph visualization. So it's converted to a vertex edge model, and then it's mapped into a node link model, which can then be visualized in with visual primitives in a graph structure. What is resource relation model? So resource relation model convert an ontology file into a set of resources and set of relation. Each resources consists of annotation, exams, and types, and the relations are annotation, exam types, and further some domains and range information. Here in the right side, in the picture, we see that resource relation model interacts with different visual representations. These visual representations communicate back to resource relation model, so that any modifications in one representation can be communicated across all of the different visual representations. Here I would like to present some screenshots from our platform. We, on the left side, we have a project structure, so a project name and some details about the project. Every project then can have several ontologies. Ontologies can be added and deleted from it. Currently we are seeing only 3 ontologies for default project is selected. We also identify different roles for users. So public user can only access public projects. Then we have key users. They can access private projects, and members can upload, delete, and modify an ontology. Project admin manages different roles. He's the administration of different roles, and then we have system admin who takes care of the overall administration of the system. The first view that we go to by default is, we call it a hybrid view, because it offers both in the textual representation as well as graph view. On the left side, we see there are some meta information, and in the middle, we have 2 columns. One column represents all the resources that we have identified in the ontology file, and on the right side, we have all the relations, which are the data types and the object types. One of the resources in this graph is expanded to see how this individual resource is visible in the graph structure and what connections it has. We also have some widget-based representation below the graph. It can be expanded for all of the resources, all of the relations. Currently, I'm showing only one of the resource. On the right side diagram, we have the textual based visualization, which can be used by the experts. Both of these visualization interact with the resource relation model. Then we have some graph visualizations. These graph visualization offer extra functionality for customization. For example, nodes can be aggregated, composite nodes can be created, they can be expanded, and different colors can be applied to different nodes so that to highlight specific information. We offer 2 notations here, so vowel notation and a UML-based notation. We have conducted a user review recently, user survey. So 7 people have participated in the initial user survey. So because we recently released our first MVP. For our evaluation, we applied 2 methodologies. One is the system usability scale, which measures the usability of our platform. And then another is the NASA task load index, which measure the subjective mental workload of the using our platform. In the system usability scale, we identify 6 sections. So one is about you, then experience with the SC3 platform, the overall task load that the user has faced, and the overall approach of the SC3 platform, and then some additional feedback and some general questionnaire about the platform. These are provided. These questions are provided in the form of a radio button between which offer from strongly disagree to strongly agree. These are the results from the system usability scale. So average of the final score is 68.21, which is marked as C grade. So our user experience with C3 platform is between okay and good. Some of the participants have experience with using C3 ontology platform, which is C+, which is good, and A, excellent. So here are some subsets of the questionnaire that we ask, with which the users were either strongly agreeing or agreeing. So these are the scores from that. So in total, more than 71% of participants agree or strongly agree on these questionnaires. Then this is the result from the mental workload questionnaires from the NASA task load index. Overall, 34.29 mental activities were required to use the platform. Yeah, so I'm finished the time. So yeah, so this is just the score. So the highest score is 54.29 to use the SC3 platform. And high amount of effort of 41.43 is required to use this platform. Thank you.
So, thank you for an interesting talk, and still questions or questions?
I might have missed this in the talk, but what kind of ontologies have the participants used to test the system? I mean, in terms of size or
we have uploaded for our testing 3 different ontologies. One is just a small example, and one is medium size, also not too big, and one is the digital reference, which is a really big ontology. More than 1,000, yeah. So it's yeah.
I have 2 small questions. First, I saw in one of the in the menu that you have there web protege. My question is or did you reuse some elements or some packages from web protege? And the second question is, in this UML notation, what is on the places for methods? What is this? Are these attributes of this resource, or what do you visualize there?
For your first.
Oh, the next slide. In this UML visualization, you have these.
Yeah, so it has the attributes are
literals. Okay.
Inside, yeah.
And about web protege.
Yes, so web protege are only we are using as a plugin in iframe for now, but we want to integrate web protege in our next MVP, so that any file that we upload into our platform, we have already installed web protege in our local server, so we are kind of using it. That's the so that's our purpose, that we will use web protege for editing the ontologies as well.
But wouldn't the ambition be to be better than Web Protégé somehow?
Sorry?
Wouldn't you start off with the ambition to be better than Web Protégé somehow, or to have new?
Web Protégé is only going to be a part of it. So our tool is basically mostly for the visualization. So we have 3 different users. So some people can understand the graph better, and some would with the text. Yeah. Yes.
So, no other question. I have also one question. Did you get also feedback of missing functionality during your evaluation?
We did got some feedback for missing functionalities. So for example, one of the results for frustration was a bit high, but it's just our first MVP. And we have, over the coming months, we are going to improve our, both the survey itself as well, and it was just our initial survey. So we will improve our questionnaire for survey, and we want it to be surveyed by more people. Right now, only 7 people internally to TIB, they tested this platform. Yes, and yeah, over the coming months, we will improve the functionalities for them.
Because I'm asking this, it seems to me there's a discussion function missing in the ontology.
The collaboration.
Yeah, collaboration.
Currently is missing, but it's on our agenda. So if you see. I didn't take it in the picture, but here on the right side we have one more column, which is not completely developed right now, and that is supposed to be used for the collaboration. So any changes would be recorded there, so that everybody else can see those changes.
Okay, thank you. And probably we can check out then the project. And
yes, so here is the link. Please, you can visit.
You can also follow then the development, the future development of the project.
Yes.
So then thank you again for your presentation.
Thank you so much.
And the next one will be Dennis Streitmatter. Why we need Archival is the presentation, and Dennis Streitmatter is from AKSW Group and is involved in research in DBpedia Association.
Yeah. Okay. So, hi, my name is Dennis Streitmatter. I'm a research assistant at the Institute of Applied Informatics here in Leipzig, and today I'd like to present why we need ontology archiving. I changed the title a bit. So, this talk is about availability and reproducibility of ontologies and their usage in datasets. But first, I'd like to start with the problems of accessing ontologies. So here at the top, you can see how it should be. You have an identifier for your ontology, which represents it on the semantic web, and is normally just is the namespace. So in the case of DBpedia, it's dbpedia.org/ontology. And then, depending on the type of request, you get a different document. So for example, if a semantic web application wants to access the ontology, it tries to access the RDF document, so for example, Turtle or RDF XML. If a human tries to access it via the browser, for example, there should be HTML documentation. This is the W3C recommendation for publishing vocabularies. And of course, there are a lot of problems regarding the accessing part. And in this talk today, I'd like to talk mainly about this machine accessible part. So a huge problem is incorrect RDF deployment, which just simply means that this redirection process is not working. So it's not possible for machines to retrieve the ontology by its identifier. Another problem is link rot or unavailable ontologies. This happens, for example, if you stop paying for the domain and you lose the control over the domain, maybe the funding for the project is over, and then the ontology is gone. And yeah, in terms of semantic WAG or machine accessibility, identifiers from that ontology can't be resolved anymore. There's also very unclear or none at all versioning, so you don't actually know what version you get when you access this RDF document here at different times. And there's also no stable citation for dependencies. This is also a huge problem in terms of the FAIR principles, so findable, accessible, interoperable, and reusable. So, and today I will mainly go into the problem of reusing ontologies. So we always had the impression that this access of ontologies were not working very good. So, but you can't argue that well with impressions in science, so we try to measure it. And to do this, we use Archivo. I introduced Archivo last year at the LSWT. And it's an automatic augmented ontology archive. So Archivo crawls on its own for new ontologies on the web using different tactics. And it also crawls every day 3 times for new versions of ontologies. And if it's find one, it's archived. And so we collected the logs from these crawls for roughly 7 months, from April 2021 to November 2021. And with this, we try to measure how bad the current state actually is. So at this time, it's around 1,440 ontologies. Of course, it changed over the time. You can see it here in the graph. From here to there a lot of ontologies were added, so this number is not that precise. But the first thing we try to get to know is how available are the ontologies already in Archivo. And here you can see on the x-axis the time, and on the y-axis you can see the percentage of ontologies where the retrieval failed. And there are sums, as you can see, it averages around 10%, so roughly 10% of ontologies are not available. But there are a few interesting moments. So for example, here around the start of May, the vocabs of vocab.dairy.es went available for roughly 2 weeks, and then they failed their deployment and they went offline again. Here's also a big gap which aligns with my vacation, and Archivo was down, but here you can see a huge spike in failing ontologies, and the reason here is that Perl.org went down, so a lot of ontologies there went offline, but the problem was fixed eventually in, I think, around 2 weeks, or 1 week or 2 weeks. Okay. But so a lot of ontologies are not available anymore. But what I'm interested in next was like how bad is it? So are these ontology only down for 1 day or 1 week or something like that? So we try to group them into different groups. And here you can see the table, and down here you can see the number of ontologies at the end of the crawl, at the end of the time period. And here you can see the number of ontologies that failed at least once. So as you can see, roughly half of the ontologies are fine, they don't fail, you can access them, but 775 fail at least once. And out of these, 709 only fail temporarily, which means in the other turn, 66 ontologies were not available at all in all of this, in the whole 7 months. Also, 40 ontologies were down 75 to 100% of the time, so In total, roughly 7% of the ontologies were at least down often or all of the time. Okay, but at that point, we could argue, yeah, but these ontologies, those are really old ontologies, nobody uses them anymore, so we tried to measure the impact on the linked open data cloud. How much of the linked open data cloud is not available or is not resolvable anymore via the ontologies. So we used the lot HTTP dump from 2017. It contains 28 billion triples and is roughly 524 gigabytes of compressed HTTP data. Here you can see the graphic how they collected it. They basically crawled the whole linked open data cloud, cleaned it and indexed it and merged it into a huge HTTP dump. And the results are here. So this is a Sankey diagram. So on the left side here you can see 100%, and the 100% refers to triples using terms which are defined by ontologies in Archivo. So what we did here, we merged the data from the lot and from the Archivo monitor to see which triples are affected by outages of ontologies. And as you can see, 54% are good. For these ontologies, would not need Archivo or any other ontology archive. But 46% of them are failing at least once, and 15% are permanently failing. So 15% of the triples use terms that are defined in an ontology that is not available anymore. And also 17% fail at least very often. And this correlates to the last table. So very often in this case means 75 to 100%. Yeah. And Archivo tries to tackle this issue by allowing you to access even unavailable ontologies. The example here is GORSS, which was not available during all of this time, but recently was restarted again. And in Archivo, you can just simply take the identifier of the ontology, use a certain version in a format, and Archivo returns always a certain snapshot of the time to you. So to get to an end, what are the conclusions and countermeasures? So in conclusion, you can say like 50% of ontologies had no problem at all. They are fine as they are retrievable and parsable and so on. And 7% of ontologies are at least often failing, or 7% of ontologies in Archivo, and 32% of all triples in lot use terms which are at least often unavailable. Okay. And the countermeasures are pretty simple. So the first and simplest one is just follow the best practices. Make the RDF available for machines and to prevent losing domain, losing a domain or something like that, you can submit your ontology to Archivo or another archiving service like linked open vocabularies. Yes, so this was my presentation. Thank you for your attention, and I'm open for questions.
So thank you for the presentation, and there's the first question.
Hi, Dennis. Thanks for the talk. I have a question which is not exactly in your talk, but do we know how many triples are not or are not using terms, or are using terms which are not in Archivo ontologies? So the other question around. I mean, you're motivated to use Archivo, and you seem to have a very good overview over the linked open data cloud. So, and you have the number of which terms are used from Archivo, but which terms are used from not Archivo.
Yes, I do. I do have the number, but the problem is it's not in the slides. It's in the paper is not yet published, but we have the number. But the point is, why I showed this is only with Archivo we can measure how unavailable these ontologies are. but we needed to do a lot of constraints to the triples, and yeah, so hopefully the paper will be published, and there is the number. I can show you.
So can I do another question? Do you have a strategy, or can you imagine a strategy how, when you are coming from a term which you find in the linked open data cloud, how you can receive the ontology? Because usually there are no direct links between used term URLs and ontology ID. So I think this is a major problem of our semantic or linked data system, that this link is not published in our ontologies at all.
Yeah. So usually there is RDFS defined by, which does exactly that, but the people don't use it. That's the main problem. And at this point, Archivo could also help. Like when you have all the ontologies, you can of course you have all the triples that they define. So you can do the reverse search again. But currently, this is not implemented yet in Archivo.
I have once published an ontology in LOV, so I know a little bit what this is for a kind of process. And my question is, what gives Archivo in addition? If I got it right, then LOV doesn't provide such, let's say, technical features like your.
Yeah.
Maybe it was the core of your talk, and I got it.
No. That would be the core of the Archivo talk, and basically that's the reason why Archivo was written in the first place, because LOV was not exactly what we needed. But for example, Archivo is fully automatic. In LOV, you basically submit via email or something like that, and they look by the eyes. And Archivo is fully automatic, so you just paste in your URI, and Archivo downloads it, and if it satisfies if the constraints from Archivo are satisfied, it's automatic in the index, and then it's stored forever, or at least as long as DBpedia exists. Sure, or hopefully forever.
So let me also thanks for providing this statistics. But I have one question. Did you also consider the importantness of the vocabulary?
The importantness?
Like I would suppose that there are many vocabularies that are more important than others.
Definitely. So this was we tried to measure it. So because of course you could say FOF is a very important vocabulary, or of course RDFS or something like that. But this was we tried to measure this by trying to find how much is it used in the whole linked open data cloud, and this is our way of. Yeah, this is our metric, how important an ontology is by how far it is adapted in the community.
It would be an interesting experiment to assume RDFS vocabulary is not available, and then you can measure the impact.
Yeah, it would be a quite huge impact, but fortunately RDF and RDFS are pretty stable vocabularies, so those fall in the category of no problems at all. They were available like all the time during the measurement period.
So, as there's no other questions, thank you very much for your presentation. And the next presentation is actually the presentation is in German language. It has some reason that we will get know in the next minutes. The presentation is held by Klaus Dessler, Gesellschaft für Mathematische Intelligenz. Die Semantik, oder in Deutsch die Semantik der künstlichen Intelligenz, die künstliche Intelligenz der Semantik.
Thank you. Ladies and gentlemen, there is a reason because I will talk in German. Firstly, I will invite myself by English. There are 3 souls in my chest. The first soul is I'm a member of the International Standardization Group, ISO Standardization Group for Artificial Intelligence. I am also member of the DIN Normungsgruppe für Künstliche Intelligenz. Ich werde ein bisschen was darüber erzählen. The second is, I have worked very actively in these groups. The second is, I'm a very experienced and old AI researcher. I was member of the first professional AI research group in the Akademie der Wissenschaften in der DDR, 1968. The first comparable group in Western Germany came 1975, also 7 years later. And as another point, I know a lot of very experienced and founders of artificial intelligence research. Later on, then I went to Western Germany and I started working in the 70s in Siemens AG in Munich, and there I founded, built up, and led the groups for artificial intelligence tools and components. This until Siemens closed his computer science activities. Later on, I decided to found own groups, own companies, and I'm now working in the Research Institute for Mathematical Intelligence in Dresden. Ja, also jetzt will ich vielleicht, the third soul. The third soul is that I looked at all these developments, that I know what all the really great researchers in AI think, respectively thought, and therefore I have decided to draw some conclusions and to develop an own system. This system has some similarity with your theme today. That is, it has knowledge graphs, but under contexts, respectively, contextualizations. Well, now I will continue with German. Die erste Idee, die ich im Grunde genommen auch von vielen der wirklich großen Forscher und Philosophen der künstlichen Intelligenz gelernt habe, ist, was ist der Geist des Menschen? Und das ist eben bei weitem nicht die Intelligenz, aus der sich dann alles andere ergibt, wie man heute so gern und oft hört, sondern das ist Bewusstsein, Intentionalität, Subjektivität, Verursachung, die Qualia, die wir haben als die Verbindung zu unserem Körper. Und dann erst kommt die Intelligenz, ich nenne sie Intelligenz 1 und Intelligenz 2. Die Intelligenz 2, Intelligence 2, is that what we are doing today with neural networks and with deep learning. It is somewhat a mirror, or is etwas ein Abbild, what Alan Turing formulated with his Turing test. Yeah. And there is an intelligence 1, which is really an interesting intelligence, which has so far not realized on computers, at least not with some success. Das ist die begriffliche Interpretation der Welt, the conceptual interpretation of the world, but that are non-lingual concepts. That is very important. So, let's continue. I gave a definition of intelligence from which I derived the definition of artificial intelligence. That was in the standardization group a very hot discussed theme, and the International Standardization Group couldn't come to a result on the concept, what is artificial intelligence? Can we derive it from natural intelligence or not? And the result was very sparse. You will see it perhaps if we have time enough. I gave a definition of intelligence and then following of artificial intelligence in this working group, but there was much discussions, and at the end we have in the standard, at least in the final draft international standard for artificial intelligence, no definition of artificial intelligence. So, yeah. Good, let's continue. Here you see some of the persons which I know partly personally. For instance, I'm very proud to know Konrad Zuse. Konrad Zuse, the inventor of the computer. Konrad Zuse, der Erfinder des Elektronenrechners. That is because I worked in a Siemens company in Munich, and in this time the Zuse company ging bankrott or went insolvent, and therefore his company was bought by the Siemens company, and sometimes we sat in the casino and eating and talked with other. Another very important person I knew is John McCarthy. He is the originator of the concept artificial intelligence from the Dartmouth conference. I don't know him from the Dartmouth conference. I know him from many visits in the United States, in California, and so on. And the third, which is really interesting also, is Noam Chomsky, the inventor of Chomsky Grammatics. Ich muss aber versuchen, jetzt mal mich auf eine Sprache zu einigen. Ja, gut. Und dann sehen Sie ja noch den unglücklichen Alan Turing, der einerseits mit seinem Turing-Test für künstliche Intelligenz doch recht viel Schaden angerichtet hat, auf der anderen Seite aber mit seiner sonstigen Arbeit großartige Arbeit für den Computer geleistet hat, insbesondere auch durch die Erfindung der Turing-Maschine. Und das ist nämlich wieder eine Schlüsselposition, die wir haben, um überhaupt zu verstehen, was heute los ist. Das ist also der Turing-Test. Die meisten werden ihn kennen. Ich überspringe den mal kurz. Ich lese jetzt vor, wir haben die heutige Situation. Die Prozessoren wurden so schnell, die Speicher so riesig, die Datenmengen so gigantisch, dass Rechner mit simplen Algorithmen gewaltige Leistungen vollbringen, die als künstliche Intelligenz verkauft werden. Das hat fatale Effekte. Warum? Weil die Begriffe, die für diese künstliche Intelligenz genommen werden, sind Begriffe, die man zur Definition des Menschenbildes verwendet. Und das ist natürlich eine große Gefahr. Ich hatte vorhin einige der Begriffe auf einer Folie da aufgezeigt, insbesondere der Begriff des Wissens, Knowledge, der Begriff der Intelligenz, Intelligence, and so on. Ja. Das ist hier jetzt mal nur, was neuronale Netze heute leisten, aber das können wir überspringen. Ich sage noch etwas zu dem ISO-Normentwurf Artificial Intelligence. We are, just a moment, the numbers. We have 3 drafts. The first draft, the most important one, that are concepts and terminology, where I was heavily engaged, although I have a small company. It is 22989, and it is nearly before its release. The second comes a little bit later. It's framework for systems using machine learning, that is on neural networks. And the third one is artificial intelligence management system, where for especially the stakeholder and the whole situation, and from developing to buying to application and so on, is defined by standard. Jawohl. Good. Perhaps some numbers. In the Foundation Standard Working Group were 34 nations, that means national member bodies, and they couldn't, due to their different approach to what intelligence is, what artificial intelligence is, they couldn't agree on some definitions. There were 290 members. The conferences were virtually, mostly in the night, from 11 p.m. to 1 a.m. You can imagine what a lot of problems. Oh, yeah. Okay, then I must make just a quick progress. Our country model is personal artificial intelligence, an understanding apparatus which only serves my own personal competence. And here you see it's named Briophone at the moment. It is also usable as a translation system. Perhaps here see the concept graph a little bit between German and Chinese, and we have a lot of approaches from inventors and so on, investors. So then I should stop my talk now. There is a lot more to talk about, but I have no time. Thank you.
So thank you very much for speeding up in the end. I was actually aware that it could be longer. The topic promised a long talk about semantics and artificial intelligence. If there are questions or
Thank you for the presentation. It was amazing. Correct me if I'm wrong. Like, I'm talking about your third soul. That you talk that you work with some similar research group, like similar to AKSW, for instance. Like, how similar you are able to tell us that your group is to AKSW, and also abusing a little bit like more like what AKSW could be like to being better in your opinion. It's for your third soul. Maybe it's the second, yes, but I think it's your third soul. Thank you, appreciate.
The first soul was to make personal AI to support any person to manage the great dangers which come for us. And the difference I can't imagine. Yes? Sorry. Okay.
Do you have another question, Andrea? Okay, so I will hand over here.
So I just would like an explanation. So you explained that the standardization body could not agree on the notion of artificial intelligence in their report. What would be your counter to this? So do you say, I've got one, or do you say it doesn't matter anyway, we need a different term?
I then propose already a different term, a really concrete term, but there were too many forces from different sides. And what the standard represents is what these 34 nations believe what artificial intelligence is. If the draft or the standard is released, then my personal answer is making a German version of that, and together with another part of the book to describe the problem. That means to define all of these things correctly and to translate all of these things correctly, which are standing in the standard, but to say what in reality is behind, which interests are behind. And so I wrote already a couple of books on programming languages, which were named Standard and Introduction to the Standard. One was this Pascaling, which was very successful, and I plan to repeat that, and perhaps later on it will be translated into English and other languages. So that will be my personal answer.
Thank you for this interesting talk, and especially for one of the first slides where you differentiated Bewusstsein and so on and so on. And what I want to ask you, you mentioned it also in your talk, that we that people make simple conclusions about intelligence when they hear this term, or even learning, machine learning, and so on. There is a very shortcut to think it's more or less the same. Machines think like we, yes. and people do the same. And even I heard in a semantic web lecture from one of, let's say, prominent professors that machine learn more or less the same as human. I'm not agree. But what I wanted to ask you, what do you think the term intelligence, when you look up in a dictionary in German, you have a lot of different meanings. So yes. Maybe it's also a little bit an issue of using this term, that we get false representations in your mind?
No, that was something I wanted to make clear, but I had not time enough. In principle, you find many, many descriptions of intelligence in a lexicon, but if you look in the depth, you see that the same principle is the basis of all of these definitions. And if people say in reality, Intelligenz is eine intelligente Maschine, intelligentes Telefon, intelligenter Fahrstuhl, they have in mind all the time not that there some mathematics are running, that is thought by intelligent men. It is made by intelligent men. And the intelligence concept in the mind of most people I know is the typical intelligence of a man. For instance, this pupil is intelligent, he can explain. Yeah, he can explain what he has understood. Machines can't explain. I had here a slide which shows or which proves, for instance, with Google Translate, they translate in nonsense because they don't understand what the sentence is in a different language. Yes, I hope I could answer a little bit, yeah?
So, there's no further questions. I have one, but probably it will then exceed the time, so it's maybe...
I'm here this afternoon, we cannot do all together.
So I also would propose that we
yes.
see you then in the
yes.
Wandelhalle, and then we can discuss a lot of these topics. I think it could be, even if you're participating in the semantic beer garden, it could be also a long evening discussing the topics.
Yeah, thank you.
Thank you for your presentation.
Dankeschön. Und so mal kann man das hier ausmachen.
So, I have to apologize in advance. We will exceed the session for probably 5 minutes. The last talk for the session is CI pipeline for generating linked open data ontology documentations, presented by Lars Peter Meyer and Kirill Bullard. Both are from Institute of Applied Informatics in Leipzig. I hope the presentation will work.
Not yet.
Technology
It's so great, everything works.
Maybe you can a little bit start introducing yourself meanwhile.
I just want to say, in the next break, this is your last chance to put your markers on the poster, because in the next session we are counting all the markers and preparing the session with the students. Okay, thank you. So after this talk, go to the poster and put your markers on the poster. Thank you.
Okay. Yeah. Sorry for the corruption. Sorry for the problems, but now it's looking like it should work, but it's still not working. Okay. We are talking to you about our idea of a CI pipeline for generating the linked open data, ontology, publishing. This is my colleague, Kuri Bulat, and me, Lars Peter Meyer. We are working at Infile, like Thomas introduced us already. Okay.
We don't have the screen right now.
We have no slides, we have no screen, but
just make it up on
yeah.
So improvise.
We are part of the project ScaDS.AI. The project is funded by the BMBF for 3 years. It's part of the bigger project consortium Plattformmaterial Digital, where beside our project 12 other projects are combined. And the screen is still not working. Okay, sorry you don't see the nice pictures.
So as long as you don't flicker and vanish, I think nobody has a problem.
Yes, just go.
Yeah. It's a little bit strange.
Yes,
yeah.
Really.
We at Project ScaDS.AI Digital are focusing on the STIR research, lots of norms, lots of ISO standards, lots of interesting STIR research. STIR is quite important. And we have the problem, well, we want to define an ontology together with the domain experts for their domain problems. There we identified 3 challenges we want to talk about today. The first is we have the interdisciplinary work. I guess everybody has something like this. The next challenge is we want to get an automated workflow. We do not want to do everything manual, but have it automated. The third one is we want to have our results stay after our project's finished, like the Archivo talk mentioned already. It's a common problem. For the...
Geht mal zur Seite und redet mal weiter und wir versuchen das hier.
Ich habe den Talk auf dem Stick. Das
auf den
können wir
hier
auch machen.
Ja, machen wir auf dem Stick. Warum nicht gleich?
Ja. Das ist der Stick with the talk.
As PDF?
Yeah,
okay.
As PDF. Oh, even I don't see my slides. Okay. Oh, difficult here. You don't know that. We defined a pipeline as our title suggested, and the first part of the pipeline is input. There we have chosen, like after a suggestion at last conference, last LSWT, Leipziger Semantic Web Tag. Exactly, that's the slide. But that's coming, okay. Okay, now we have pictures again. Ah, perfect. Much more easy. Okay. We are already at the pipeline. The first part is input of the pipeline. There we have chosen to use a spreadsheet input, quite similar, everybody knows it. Easy for our domain experts to understand. The next idea again, to keep us out of work or to keep our work minimal and make it sustainable, we used a CI pipeline, automated CI pipeline. There we have the spreadsheet conversion. There we have a tool for converting the old files to a published version. Some tests can be included. Nextflow again is a keyword we will mention here again. We are integrating our work in the Nextflow project. And now I come to a next step, or Kirill will come to a next step, the publishing part.
Thank you, Lars. So, while running the pipeline, the last step of our ontology pipeline is to publish our ontologies. For that, we are publishing the different representations like turtle files, HTML, RDF, to our storage location. Right now, the storage location is located on GitHub, but it can be interchanged. So we decided we don't have a domain on our own, and we also don't have servers that we are kind of utilizing right now because we want to have those parts kind of interchangeable. And since we are utilizing currently GitHub and might change the storage structure in somewhere in the future, we decided we want to use a redirect service. And for that, we are using W3ID. We are not using Perl because at the time we started the project, Perl was in the transition from the normal Perl, I don't know what the body was, to the Internet Archive body, and the interface was not working. It had a lot of errors, so we ditched Perl. And I was also not very convinced by W3ID because it has a very complex interface, but we decided to go with it because it has some features. Yes, we claimed the namespace of W3ID/Steel. That's a very generic namespace, and we are planning to do even more ontologies on the namespace. It's not only just for the Steel, but the whole Steel domain, but we are only focusing on 2 parts of it. With W3ID, we are now then creating redirect rules. We are using, based on the cool URIs for the semantic web suggestion, the 303 code. And depending on the accept header, we are redirecting to the different representations. So if you are wanting turtle, and or if you want HTML, you will get the HTML. If you want turtle, you will get the turtle. But you don't have to specify it in the path in the beginning. Can I move the mouse? Okay, you don't have to specify in the path of the URI you're using it before. This is nice because we wanted to have an ontology that can be used by humans and machines at the same time, without changing the URIs, but it's quite normal. Also what we did is we fragmented our ontology. We don't have only the whole ontology in one file, but we also have every concept entity in different representations, so we can kind of link only one concept and not download the whole ontology every time we need one thing. And this is also, since we are using W3ID, we can use regular expressions for that and don't have to specify a huge mapping convention for all the files and everything, but we can just add, like, yeah, concatenate the string, and that's it. Since we know we had the last slot, we cut it already a bit shorter. So let me summarize everything once again. So what we present today was how we proceed interdisciplinary building the ontology. So we had the input as spreadsheets. We tried to fiddle around with Web Protege, with Protege and everything else, but all those tools create additional complexities, and those were not very suitable for domain experts that well, never used ontologies, or at least don't have the time to learn all those tools. We presented the automated pipeline that kind of transfers the outputs into a representation, so the experts only have to work with spreadsheets, and I think most from the material science department are very well versed in using spreadsheets. The infrastructure we presented is low maintenance because we kind of piggybacking on other people's infrastructure and services. We can run everything on GitLab runners, on GitHub playbooks, on any other services, and we don't have to provide anything else. This is quite nice because we don't know what will happen after the project ends. This is always the problem. You create an ontology, project ends, gone. Yeah? Maybe 3 years later, gone. And what we are currently doing is we are improving the tooling for W3ID, because W3ID, as I told already, has quite complex infrastructure to organize everything. And at least for testing the links and the redirects, we're creating some tools. Also, we want to add more pipeline modules. So right now we have W3ID and we have our own data management system that kind of in our consortium is used, but this is not public, but there will be multiple more, modules that can be attached to a pipeline. And what we want to do in the future is we want to try to work with W3ID and extend something like proxy capabilities to the service, so the URIs don't change and you can just copy paste it from the address bar and so on, and you can have also multiple redirections to multiple servers if one of them goes down. We also want to integrate our pipeline into OntoFlow modules to extend it and like have a generic pipeline that kind of takes inputs. OntoFlow currently was designed to take chalk inputs, a graphical input, but we want to have OntoFlow like that, so we can have multiple inputs like Excel spreadsheets, chalk, spreadsheets, whatever users choose, pipe them through, have tests in that, and then also just choose the representation you want to have in the end. Improve the work for W3ID, okay, it's not important, yes, and the evaluation will be done in the end, by the end of the project, and see how the acceptance was received by all the researchers. So, thank you for your attention, and we're over time, but I hope we have some questions still left.
Thank you also, thank you for being fast. Questions? Yeah.
I'd like to ask, what is your experience with giving domain experts a spreadsheet to do their modeling in? Actually, maybe just to understand, does somebody like a modeling person create this spreadsheet for them, or is this really close to the data that they're used to seeing? The reason I'm asking is I see a lot of results that are strongly biased towards really outdated views on the data when we give people spreadsheets to model, and I'm sure you must have come against this as well if it's a problem.
Our spreadsheet is not based on the data, it's a general ontology or concept input spreadsheet. So something like the label description, some notes, some relations, something like that. So we provide the spreadsheet, we provide the tooling for converting the spreadsheet, but the domain experts can put in their knowledge in there.
So somebody has prepared this for them, basically?
Yeah.
So I have also a question regarding the HTML representation. Do you use a tool for this, or do you have a special representation, maybe close related to the tables or to the spreadsheet?
Well, we're using JOT to just serialize all the triples that are in the database. So we can use Pilot or whatever the other tools, but currently we are using JOT because just like simple is syntax, and also was developed in-house partially, and also with a sensor and Nathanael together.
Just the question is also more like the experts from engineering field working with steel. Do they understand then these representations? Or is there a special effort in the project for publishing, like readable?
We have some special representations that we are working together, where we have Sparkle queries combining the data that are coming in that the experts are very interested in. For once, it's called a material card, but this is currently in development. This is kind of a digital representation of one instance of a steel for that purpose. So you can just use it as a, like if you ever did 3D modeling, it's like picking a texture and putting it on your crash simulation. So you're saying your front bumper has the material, whatever, HT something. I don't know the numbers. So, but then all the properties of that steel will be used in the simulation. and how this material card is designed. This is domain specific for us. So we are designing the representation for that.
And I guess we are quite happy or lucky. The material science guys we are working with are quite computer fit. They work all the day with the data and computers, so it's not the worst partner we could have.
Yeah. That sounds as a very interesting project, and maybe you can present the next result on the next Semantic Web Day. Thank you very much for. Is there any questions? I assume the coffee break is approaching, and I just want to remind also to make the vote. And thank you very much for your presentation.
Was liegt denn?
and I'm going to be your chair for the session. And our first presentation is by Edgar Marx about empowering product discovery through biodiversity.
Thank you. Hi. Okay, I think I'm gonna use the microphone because I cannot actually see my slides. So I will ask you excuse also because I'm gonna be turning time to time. When I was preparing this slide, some institutions that I collaborated with got a bit in discussion what I will add here. So I add a bunch of organizations that I contribute or I work to in one or another way. I'm actually a member of AKSW. I work in Essenza. I also work in HTVK, and part of this presentation is related with the work that I'm doing there. I'm also guest researcher at INFI, and I do a lot of contributions to DBpedia with Google Summer of Code. Okay, so when I was working this presentation, I decided to not do anything too much technical, but rather to draw attention to the aim of the project. So do something more abstract, in an abstract way, and maybe flourish some ideas in the researchers that are here, or plant some seeds in your heads. And to start this presentation, actually, I will go through some slides with some plants that you may or not know it's make part of your life daily. And first plant, someone can guess what is this? Which plant is this? I guess nobody. So this is an orchid. This orchid is native from Mexico. It was first used in the more or less 1,000 years ago by Aztecs to flavor. It's called vanilla. And a lot of people don't know that vanilla actually is made from the fruit of an orchid. But I want to plant one seed in your head. In the world, there are today known species, 35,000 orchids. 35,000. Is it possible so that just one can produce something so special like vanilla that contribute to the global market with $44 million yearly? And is in your ice cream, is in your milk, if you don't know. Okay, the second one is cacao. Sorry, I already jumped to the name. So cacao, as you may know, we use to make chocolate, but it's not the cacao, the fruit that we use to do chocolate, but the seeds. It also was first done by the Aztecs, was brought later to Europe by the European navigators. Today, the method that you do chocolate is a little bit different, but still has large influence. You still use the same fruit. Coffee, everybody had the coffee today. But interestingly, here, 300 years ago, not so far from here, a German researcher, Ferdinand Grünsch, had first isolate caffeine from coffee. And today you know that these invisible things, these molecules that are in the plants, they are not so special. We can actually fabricate synthetically some of these molecules, and you can find other plants that contain the same molecules. And here is one example, opium. Opium is used already 200 years for anesthetic. Still today we use depend highly on opium for certain types of anesthesia. It's still used in medicine. This one here, you may not know, it's called vinca. You may have in your garden or have seen in some garden. And we are using for cancer treatment. It's using for radiotherapy. So I think in these 4 first slides I already convinced you that biodiversity is really important. Here is a little bit a klein or a small little bit timeline of some discoveries that we have related to biodiversities or molecules that we extract from some of plants and animals for medical treatment. Is there anybody here that has hypertension or use medicine for hypertension or something like this? Because actually the captopril, that is a medicine for hypertension, actually is extracted from the poison of a snake. And I think few people know this. Okay. So this arises one question. Can we do it better than we are doing today? Of course, there are a lot of research going on, and the discoveries are fantastic and so on. But can you do it better? Because sometimes I ask myself, people really don't realize the importance of biodiversity, or the importance that a biodiversity has, or impact that it has to us. And you know, as a researcher, the problem is that most part of our time, we stay in the red cross here. Some researchers stay actually the whole time in the red cross here, not finding actually anything. And the problem with this is that research is really costly, really costly. So if you see some examples that I gave, we basically engineer the methods that already exist 1,000 years ago, developed by other civilizations for produce our goods. Of course, there were some advances, but I believe, and that's why I'm here, we can do it better. Yes, we can. So, what is this about? We can collect and catalog the chemical compounds existing on these biodiverse plants across the world. You can organize, catalog this, make interlink. Then you can use the data to train machine learning, so you can discover other products, other plants that can produce similar chemical compounds, perhaps even more than other plants. You can give them this tool for researchers so they can find where to find these chemical compounds that are so important for combating disease or to make food or flavor. And then with the result, you can refine the data and the model and produce new products. And by doing so, I believe the researchers can, and the industry can then realize the importance of the biodiversity. So what we're doing here is tackling the problem in another angle, in an economic fashion, which I believe is more useful. I forgot to say. And by the way, this is not just an idea. We wrote a project. This project got accepted, and I'm really glad. We have a consortium of one German university, the University of Applied Science, 2 other universities in Brazil, the University of State of São Paulo and the University of São Paulo, 2 large institutions of research in the world. And this project is being funded by DFG and FAPESP. And we have an industry partner also, that is Essensa. I could convince Sebastian to join this consortium. And we, of course, are going to build some knowledge graphs. But why I'm really motivated is to work with Brazilian institutions is that, first, I put this picture here on purpose. You may not know, but Brazil is really huge. So we have 28 federations in Brazil, and just one, which is called Amazonas, is larger than France, Spain, and Germany together. And there is still room to put 60% of Italy there. It's enormous. And this is just one state. if you get the Amazon forest, it goes beyond the state to 2 or 3 other states in Brazil and other countries around. You're going to see in another picture. But just to give you a dimension of how much biodiversity there is there. The second, and there is people still in Amazonia living that had never had contact with someone else that was not the tribe. Still today. So another thing is that Brazil has something around 21% of all living species. So if I give a shot, I had 20% chance to find something there. So why are you looking around? Just go there. And the reason is that a lot of people know the Amazon rainforest, but Brazil has the Atlantic rainforest, which actually is super beautiful, and another 4 biomes, Caatinga, Cerrado, and subtropical grasslands. So sometimes I'll say the names with a Portuguese accent because I'm actually Brazilian. So sorry for that. And another thing that we are really lucky is that our consortium partners, although 20 years ago there was no machine learning, I just have 1 minute. There was no machine learning. They already started to catalog what we just said. So they start to build these catalogs, and you have a database with compounds from Brazilian native species, a large database. And that's why we're working with them. It's a unique database. We start working the project. We started already also to do automatic generation of the knowledge graph based on scientific articles. We already have some results. Some are really good, others not so. We have to work on that. But I'm really motivated. We also want to create a kind of, I'm put the name here, but maybe change, ChemNet, which I envision is one of the largest or the largest knowledge base with chemical compounds and plants. It's very important to have chemical compounds. It doesn't matter. It doesn't help too much to know that there are many species if you don't know what to do with them. And we want to also create association so we can gather other institutions that are interested on research on this data and also keep the research on the field right there and maybe expand to another countries. Thank you very much. I would like to end this talk paraphrasing my favorite, I would say, researcher, Carl Sagan. Somewhere, something incredible is waiting to be known. Thank you very much. These are my contacts. I will be glad to answer some questions.
Thanks a lot. Have we got any questions for Edgar?
If you have more time, like which content that was like missing in the presentation? Because I found interesting. Very well.
It's maybe, okay, maybe as interesting to know what we are linking, how you're building the knowledge graph. I know that that was a bit generic, but as I explained in the beginning of the presentation, we want to just plant a seed in the head of the researchers or people that are here that work in different areas. What I didn't explore there is how we are building the knowledge graph. There are a lot of knowledge graph out there. There are a lot of bio data out there, or some even already organized in the knowledge graph, but what is missing, all of them don't have, is the linkage between which species, where this species is endemic from, and what these species produce. None of them have, and we have.
I have a short question, but I'm not sure whether I got it right. First, you started with the kind of process, how people come to new products. And the idea, what I had, is that a lot of these inventions are a kind of chance, or a lot of experiments are done, and then if you are lucky, you get a new product or things like that. Is one of your statements that having that kind of knowledge graph, there would be less random success and more, let's say, controlled or definite success? Is it true or not?
You went to a different. I think you got a really important angle, but that's why I put this picture right in here, because I built this artificial knowledge graph on purpose. And thank you for the question, so I can explain that. I had the opportunity to explain that. Everybody knows that caffeine was extracted first from coffee. I just said here. But do you know that caffeine can actually also be extracted from a plant in Amazonia called guarana? Guarana, maybe in Germany would be guarana. You can buy in Kaufhof here, by the way. Now, the caffeine from guarana, it lasts in your body 2 hours more than the caffeine from coffee. And, right, the knowledge graph is showing here, the caffeine from guarana is used in Red Bull, while the caffeine from coffee is used in Coca-Cola. Now think about it. What if you switch? You create a different product. So maybe you were exploring different markets. And maybe the people that created these products, they didn't know this. They didn't have this knowledge to build these products. So now with this knowledge graph, what you enable is the company go there, okay, I want to build a similar product. What else I can do? What are the things there? Oh, this here is interesting. Oh, it's more even produce, like the caffeine from guarana can give you even more power to you. So you can play with these things. It's just an idea, but powerful one.
Great. Thank you so much for your talk, Edgar. And now, the next talk is... So our next talk in this session is by Dr. Matthias Jurich from IT Brock Solutions about pharma semantic search.
Okay, yeah, thanks for the introduction. I think I'm going to imitate Edgar, as I also can't see my slides, and use that microphone. So thanks for the idea, Edgar. Yeah, so this is for the next slide. Okay, perfect. Yeah, welcome to my talk. First, I'm going to quickly show you the agenda. I'm going to start explaining you a bit what Brock's IT Solutions is, because probably most of you have not heard of us in the semantic web context. Afterwards, I'm going to give you a bit of a background and describe the goal of the project that I'm going to present to you. Then I'm going to talk a bit about the technical challenges that we faced when working on the project. And then I'm going to explain the solution for you and tell you a bit about the... Ah.
Ach so. Und jetzt wieder aufmachen, oder was?
Ah. Thanks a lot. Okay. Yeah, last step, I'm going to tell you a bit about what and how did this help the customer. First of all, yeah, who and what is Brox IT Solutions? It's a consulting company. So when in the first talk, the consulting problem was mentioned, of course I felt personally attacked because that's my job. Yeah. Just kidding, of course I did not. What do we do? Yeah, we've been founded in 1998 by Hans Christian Brockmann, which some of you might know as he is involved with Sensa. So he's our CEO and he's also involved with the Sensa. Originally, our headquarters is in Hannover. We have offices in Hannover, Wolfsburg, Leipzig, and Stuttgart in Germany. And we mostly focus on the verticals, yeah, automotive and manufacturing. So this is where most of our customers are. And a little bit on, and in that area, we mostly do process and IT consulting. We have some research partners, that is the University Leipzig and the DFKI. And we have 4 departments. The first is the IT sourcing management department. Then there is IT architecture and infrastructure. We have IT lifecycle management. And then the area that I am from, that is information management. Information management deals with all kinds of things with knowledge, information. And we are right now mostly focused on linked data and semantic web topics, which is also my background. Okay, who are our customers? As I said, it's mostly automotive focused. So we have VW, we have Porsche, Volkswagen Financial Services, Brose CTEC, and ZF, which are also very important in the automotive sector. But we also have other customers. So, for example, we are also working with Siemens and with Merck and the Bundesagentur für Arbeit and Finanzinformatik Technologie Service. Okay, so much about the company. Now let's get into the project that I want to tell you a bit about. To understand that, I first have to tell you a bit about how drug development in the abstract way works. We had some thoughts on that in the previous presentation already by Edgar, right? Which I think is quite nice because that fits very well to what we supported with here. So the drug development process has basically 4 phases before you can sell your product. And it is very long and it is very, very expensive. You start with basic research, so where you get the ideas. Basically, that is what Edgar was talking about. Then you do some preclinical trials. Then you go on with clinical trials. And then you start getting involved with the regulatory process. In the first 3 phases, a lot of data is used, and it's usually some kind of internal data in internal databases. Sometimes knowledge graphs are used. And after that, we get to the regulatory part. This is where you need to write documentation, go to a regulatory body, and then they will look at your documentation and say, okay, that's fine. Or they're going to say, oh, no, there is something missing. We need more documentation, stuff like that. So, what is the issue? Sometimes the stuff on the left, so the internal R&D data, and the stuff on the right is not aligned anymore after some time. And when you are some years behind that process, so you did write all of those documents, it will be hard to integrate that data back to each other. So it will be hard to know what kind of products and substances and stuff like that are used where are they registered. And you can imagine this can cause all kinds of problems. So, yeah. And this was basically where we helped our customer. we wanted to do two things basically. First, we want to recreate that integration. So link back the data that we have in the regulatory domain to the data that we have in the R&D domain. And as we heard, data integration is basically the killer feature of knowledge graphs. What other way to do that than with a knowledge graph? So this is the first requirement. The second part, integrating data is great, and that's important, but users also need to be able to use that data. And that is the second part that we looked into. So we wanted to provide a front end for exploring the data, and this front end should be accessible to users without a technical background. So a Sparkle endpoint is not enough. That leads to two domains of technical challenges, basically. The first is integrating the data from the R&D and regulatory domain, and the second kind of technical challenges is making the data available to the users. Luckily, we did not have to integrate just the plain PDF documents. There was some text pre-processing done before that, and we were able to access semi-structured data, so Excel files basically. However, if you have ever worked with text-mined data, you know that data quality is then always a significant issue. So this is one of the topics that we needed to look into. And also, we wanted to integrate that data with other sources later on, and that should be done in a knowledge graph. Luckily, the substance data and the R&D data we already had, that was already present in a knowledge graph, so a knowledge graph was really a no-brainer in that case, right? And the second part of the challenge, the second technical challenge, was to provide the non-technical users a front end. And we thought the best way to do that would be to use a metaphor they know. And a metaphor they know is everybody uses search engines, so we use the search engine, basically. Okay. So a basic look at the architecture, just a very abstract look. We start with the submission documents, then we get, via text mining, some Excel files, do some data cleansing and linking, and then integrate that in the knowledge graph. Data cleansing and linking is done to the internal R&D databases and to the organizational graph data. Then this data is transported to a search front end that is basically built out of Elasticsearch and SearchKit. Okay, let's have a small look at the data integration. So this was mainly done with standard ETL software. Everyone that has worked with some kind of ETL has probably heard of Pentao. They also have some integration with RDF data, which is not as nice as more sophisticated solutions, but still does the job sometimes. And we also used some Sparkle queries to extract the relevant information. And then we stored the result in an RDF graph, in the RDF database. For the search front end, well, we basically built a two-component system with ingestion and then an Elasticsearch with SearchKit in the front. So SearchKit is a really nice way to implement a front end for an Elasticsearch if you ever come across a similar problem. Okay, since I don't have much time left, how did this help the customer? Basically, doing what we did can help in three ways. First, it can reduce risk. If you discover, you remember this long process before we can sell a product in the pharma domain. If something goes wrong anywhere, this will cost money. So that is a significant issue, and this is something we want to work around. So that can reduce risk. The second part is cutting costs. If you manually want to connect products and legal entities and stuff like that, then you will have to browse manually through all those files. That costs time. You can cut that. Also, integrating that data with other information, since it's already in a knowledge graph, is going to be very fast. And what you also can do with that solution is you can, of course, filter by different aspects. So you can see what kind of products have already been released in what market, and what markets are maybe unexplored. So this will help a lot. Okay, last slide. What did we learn? We learned a bit about data issues in the pharma regulatory process. What the users in the domain need, that is data integration and a simple user interface. How did we do that? ETL tools, a graph database, lots of data cleansing, and standard search solutions. And I told you a bit about why this is useful. So cost reduction and risk reduction mostly. All right, thanks for your attention. If you're interested in topics like that, please feel free to contact me, and I am open for your questions.
Any questions for Matthias?
I'd be interested in your experience with data cleansing. How did you do it roughly? How did it work?
So mostly that is still built on rules. For example, typical problem, you have Gesellschaften mit beschränkter Haftung, GmbH, Aktiengesellschaft, AG, Straße, STR. Straße with sharp S and double S and stuff like that. All of that, you get around that mostly with rules. I have not seen a way to do this very consistently without doing things like that.
We have time for another question. Maybe I do have one. So in this data cleaning process, were you able to do it all on your own within your team, or did you have to involve also staff from your client?
Yeah, of course we had to talk to our clients. While we gained some expertise in that domain, I am not confident that I can always say which substance is the same as which other substance. So of course, that is not as easy.
All right. Thanks a lot for your talk.
Yeah, thanks.
And next up, we have André Valdestilas talking about the intersection between material science, engineering, and the semantic web. You can have this one, but you can also use the
that's good. Let's fix it now. That's good. Well, good afternoon. So, my name is André. I study here like 6 years, like I spent off my life here doing my PhD with the AKSW group, and I'm a member of AKSW since October 2014. So, and if you allow me, I will continue the presentation from Creo, talking about material science and semantic web. So, the intersection between material science, engineering, and semantic web. So I will start talking about like the place that I work, quickly, motivation, why we did this, like the state of the art, where we are actually, and how we manage this at BUN, the place that I work, in conclusion. So the Federal Institute for Material Research and Testing, BAN. So we are like actually 1,606 employees distributed in 10 departments between six divisions and sections. So we have like many active areas of research, and one of those is like semantic web and material science for sure. And so so my group inside BAN is called eScience. So there's it. So it's the S.3 if you go there to find us. So we are active like quite early, quite like recently, like since 2020. We are more than 20 employees. I say more here because we have a kind of like students that like spend like some internship like very quickly, and they go like in like stay there like 1 month, 6 months more or less. That's why I say more than 20. So, and we have our activities in the context of national and international activities, and we work straightforward together with Fraunhofer Materials, more specifically talking about the project MatOLab that is included inside Material Digital, which was explained, like was introduced by Krill before. So we do research and coordination and consultancy. So, talking about the intersection between material science, engineering, and semantic web that we do at MatOLab. So, firstly, this intersection started according to the literature that we started doing. So, this started in 2008 with ontologists describing concepts from materials, like simply to describing concepts. Then comes to like people start in 2016 more or less to do the conversion of tabular data to RDF, like more or less more straightforward talking CSV to RDF, like to convert to triples, but not a kind of organized RDF knowledge graph yet. And since 2020, people start to talk about fair data, which in this event from 16 presentations, 8 presentations mentioning fair data. And I heard this fair data a lot since I started with material science. And I think I will heard like a little bit more, like I will listen a little bit more about fair data according to this prediction. So, then not satisfied with this state, we arrived to some research questions. For instance, what are the state of the art that we are dealing for? Like, what are the state of the art of approaches like material science approaches using actually semantic web? Like, which semantic web are actually applied to material science? Like, those semantic web influence really the quality of material science experiments, like how much? And what are the open challenges on this intersection between those two areas? Of course, semantic web is a kind of tiny, material science comes since like the man's man, like, so. One way that we start like to collect this state of the art, it's like we have like, as you know very well, like search engines like digital libraries like Google Scholar, ACM library, and IEEE, journals and conference, like more than 20,000 papers. And then we should like do some criteria, like to be specific, what about we are talking. So then we like spend like more, I think, 6 months of like doing this, and we only have like 17 papers like that really reproduce the state of the art. Of course, I can say like more about this selection criteria, but not now because it's kind of extensive. So, which semantic web are like really like, which area are like people are like more talking about? As you realize, like during the talks, like big and fair data, it's like the most like topic that people are talking, like followed by converting like tabular to triples. So an example, like the intersection between big and fair data and like some material science areas like material design, polymer, nanocomposites, and so on the other hand, like there is material science areas that only need like provenance. Okay, so challenge that we have at BAN, that we are actually like working and is considered like a kind of state of the art as well. Like for instance, visual representations of material science methods. Like a material science method, firstly, is a state diagram. So then like they are like, as you can see, they are like directed graphs, and RDF are directed graphs. So then the best way to represent our material science method is with RDF. We have the natural MSA queries, where we use natural language processing to make, to don't be compulsory to the final user to use Sparkle queries. We have the Mat portal, ontology repository only for material science domain. That's part of kind of Ontoportal Alliance, together with the Stanford University. We have the Lab Digital, where like it's an RDF graph to store material science data provenance from experimental data to model prediction, together with some machine learning. But the basic structure is like from the raw data to generate RDF graph. And we have the SLAM that implies to use ontology embedding in order to improve the prediction of ideal material candidates, like, and also include mapping tabular data to RDF, some machine learning techniques, and like one like proof that like semantic web is like really helping. Like before, like was like take like between 82 years to 408 years, and now like you can do like in days, like. And so the conclusion that like we are working in a kind of detailed systematic literature review, including those two areas. And we want to illustrate the impact of applying semantic web to material science. And in order to do this, like we include the specific open challenges on the intersection between those two areas. And the next step is to elaborate like more approaches involving the open challenges and the state of the art. And that's all. Thank you for your attention and sorry for being boring.
Thanks a lot. Have we got any questions in the room?
Just for clarification, the graphs you build, do they go to the level of the documents that you find, or do you go inside the document and somehow represent what they talk about as well? That's something I didn't quite get from your...
The graph that we made it's basically about the data from other experiments. Like for instance, like we have like tensile test. So you start like with something like you get like some wire like this, and then you stretch, pull, and then stretch like stretch, measure, stretch, measure.
It's not documents you're indexing, but you have real experimental data that you. Okay, then I misunderstood you. Sorry. Okay.
And tabular data, I mean like not only one format of CSV, and we have like more, but I can talk more.
Do you standardize the materials also?
No. Okay. I'm like 10 months learning material science. I'm so much better.
Any other questions for André?
Yeah.
Well, thanks a lot again.
Almost.
And so the next talk is by Klaus Stadler about the mobility index. And I'm very curious to see what it actually means.
Oh.
Great.
What resolution does the beamer accept? Full HD, I suppose, right? You can also try.
I thought we have all the.
Okay, and I just want to present all the live thing, but maybe in the worst case I have to just stick with the slides. So we don't get working. Okay, this one seems to work. All right. Then let's try it with this one. Or no? What? Okay, then have you? No, I can also do the link. Then yes, it can also do from this one. Okay. Let's be prepared.
It's already on.
Yeah, yeah, it's already there.
You can find it.
Yes.
Nein, no, it might need one.
This one.
Yeah. Okay, now can I quickly open the browser, then I can load the link in the meantime? Okay. Okay, so, okay, nice. Now it's ready.
Okay. Then
just.
Okay, sorry for the delay. My name is Klaus Stadler. I am from Institute of Angewandte for Applied Informatics in Leipzig. And I'm going to present Mobility Index, which is basically a feasibility study for reachabilities between cities in Germany using semantic technologies. So the overview is quite simple, the motivation, the approach, and then I give a quick demonstration, and of course then the conclusion. So the motivation is that there is several community projects such as OpenStreetMap, and they have created enormous amounts of data for freely available geographic data and the corresponding ecosystem. So you have routing, geocoding, visualizations, and you even have special applications such as navigation of blinds. But like on the macro level, there is not a system to quantify, okay, how good are we reachable within, between these different places, like cities, counties, and municipalities. We have knowledge graph technology, so it's like, hey, can't we integrate it and get a perspective on that? And so what we need to answer is to analyze reachability is, okay, like how, when we have two places A and B, so how long does it get from A to B? What's the best route? Best can have different meanings, depends on the context. So do we want to optimize for costs? Do we want to optimize for risk, like congestions, or maybe now with Lufthansa flights that don't fly? Also ecological considerations like CO2 footprints and so on. And I can already say that, for instance, with costs, we didn't get one data set which was a comprehensive overview of what the public transport costs across whole Germany. So it was just like some isolated silos which we found, but not like, okay, here's the whole network and this is what it costs. Yes. So how did we compute the index to analyze reachabilities? So what we want to do is we want to analyze different transport modes like flight, trains, and cars. And obviously there has to be a rank by travel times or distances, and well, we somehow need to aggregate and normalize those distances and times. The primary challenge is, of course, like, okay, where do we get the data from? Also, not every city has a train station and airport. How should we handle this to make it comparable? And also, there's a temporal dimension. So even if we know that A is reachable by B or the other way around, like when is the connection? Well, and in any case, so the rough idea is basically really finding out how can we come from A to B, and then take the time, which is probably the most relevant aspects of it, and compare it to like some kind of centroid. So the assumption is that cities that are close to the middle of Germany, whatever the middle is, there's different definitions of it. The closer it is, the more advantages it should have, because like it's better, it should be better reachable from all the other cities around it. Or conversely, a city on the border is probably it has long distances across whole Germany to the cities on the other side. So so this is kind of what goes into the index design. So what can be what are use cases for this? Well, I mean, for instance, the discussions back then about, okay, do we actually need flights within Germany, or can we get rid of them at all? And for instance, and the idea of this feasibility study was, for instance, was to get an perspective on that, or to make it, well, to show how far we get with the data sources that there are to realize that. For this feasibility study, so we took the 100 largest cities for this analysis. So that means it's like not a comprehensive analysis of whole Germany. It's really to check how far we can get with the technological aspects here. For data acquisition, we used OpenStreetMap, Lufthansa, the Bahn API, and the data is from around March last year. For the routing engines, we used, one was provided by a consortium partner, Locus Lab, and this was used to compute reachabilities between cities. And then we also, well, when going from one city to another by flight, well, they first have to reach the airport. So for this we use an open source routing engine, the open source routing machine to compute these. Yeah, and of course the APIs, so BAN for instance, well, they also do, well, you can give it two cities and it gives you basically the route for it. Yeah, the integration was done in RDF. The index computation, we could do it mostly with Sparkle, and the demonstrators based on the Vaadin framework, just to give the technical stuff. Yeah, that's basically just a pretty standard architecture. Data sources on the left, you collect them in a catalog, structured and unstructured. You do the RDFization, integration, then the analysis, load in the Sparkle endpoint, and it goes into a demonstrator. Yeah, I think I can just go to the demo because the technical stuff I can explain on the way, or maybe should I mention it? Okay, maybe just to compute how the ranking is. No, I'll show it in the demonstrator now. It thinks more grasp. Is it F11 or so on Mac to go full screen? No, function. Top left green circle, this one. Huh? What? Left, this one. Ah, okay, yeah, that makes sense. All right. Oh my God. Yeah, okay, yeah, I'm not used to Macs. Okay, so this is the demonstrator. Yes, I will. It's also on the last slide then, how you can log in. Password, username and password is moin and moin, but yeah. So basically this is like now the list of the 100 cities which we used. This is all in RDF, and we can just click and see have it all displayed on the map. I don't know. I thought it should show the name, but it doesn't matter. And anyway, so what we did basically is for these 100 cities, okay, I'm really not used to Macs. Basically, we computed the reachabilities between the cities, which basically gives this matrix where for each city we have computed the number here is that's the travel distance, travel time now. Can see anything? Yeah, I think it's okay. So we have the three transport modes, which is car, Bahn, flight, and no, I didn't want to click. Anyway, car, train, and flight. And each cell now, you can see it changing behind. But anyway, each of the cell now contains the minimum travel distance across all these mode E. And now for each city, we can now check how well or how fast we can get to all the other cities. So how well it's connected to every other city there. And when we take the times here, so you see that the more dark green it is, the smaller the number. That means the better is the connection. And basically, we can now sort from the times. We can also go to a relative rank. So that means like, for instance, here we have going from Chemnitz to Dresden. That's basically the fastest connection from Chemnitz to all the other cities which were considered. What's the right click on a Mac? Any case. Yes, does it exist? Whatever. It's okay. Anyway, so it actually should show which of the transport mode, car, flight, or train was the fastest to get to this number. Anyway. We also have, like, this was our first visualization of the matrix. The problem is it's not very responsive, so we created another one, which now it's a bit, which can be zoomed in more closely. So what I just want to say is, like, cities that where the line is more green, like they rank higher. basically in the end. So that means like, so from going from this city to all the others, the more green it is, the better its rank. This can be summarized in a table. Sorry. Okay, here now we have it. So for instance, so that means Frankfurt am Main, so among those 100 largest cities, Frankfurt am Main won because it has the best reachability. So that's the column here. And when comparing to the center of mass, so this is now the centroid, based on the population. So as I said, there's different types of center points. So like these you can choose between. They are all rather in the center. What happened now? Escape, thanks. Okay, whenever okay, anyway, so you can choose it based on the No, I don't want to open the dictionary. So basically you can choose a center based on the center of mass or the population, or you just make a bounding box and take the center of it, or the point that is that has the minimum distance to the border and so on. In any case, so like depending on which you use, like this is like the green number means that it's better than the center. That the rank to the reachability is now better than the you can rank the cities by the distance to the center of mass, and you can rank the cities based on the reachabilities. And this 13 means that its rank according to reachability is like 13 ranks better than when comparing it by the distance to the centroid. So for instance, what I can do now is, for instance, if I remove the flights from Frankfurt, for instance, then you can see that it will go rank down. So now it was number 1, before it was number 1, and now it ranks number 9 in that case, for instance. So like the flights, that they make a difference in the reachabilities. Also, when I go back to the matrix, you can see that the matrix has changed, so the times are different. All right. Yes. Maybe as a last point, we can also basically draw a distortion map on Germany based on this ranking. So for instance, you can see now Munich, for instance, it used to be quite on the outside, but thanks to the, oops, that's Munich, the other one, it was moved more to the center of Germany. You can see Flensburg, for instance, which was like, it moved actually farther away. Yes. You can also see that the Ruhrpott here, for instance, so that was kind of a cluster. So most of the 100 largest cities, they are around in this location, which gives kind of a bias. But overall, basically, the thing is that that the technology, you get quite far already with doing it. The data behind is in Sparkle endpoint, and you can also, basically browse the connections, so you can see when you click. You can basically activate different connections. Yeah. Just to find one with an airport. I don't know, Berlin. Yeah, it doesn't matter. So basically, what I want. Yeah. So in any case, so if there was an airport, then you would see there was like a line string going to the airport. Then there was the straight line to the other airport, and then another line string going to the target location. So it's like it's not that simple what we did there. In any case, thank you very much.
Thanks a lot, Klaus. Any questions?
Thank you for the presentation. I have two short questions. One of them is, how do you consider the distance within the shortest route? And the second one is maybe a bit beyond the scope of data integration, but do you use for the mobility index multi-objective optimization for the best result as well?
What was the last one?
Multi-objective optimization, or only for one factor to be the best resolution?
No, it's just we just use one. Okay, yeah, we just used one factor in the end, so it was really just the travel time. We tried out to get like carbon footprint and like to get more data on to rank, to put more parameters in, but we didn't find comprehensive data sets that would cover it for all these cities. So in the end, basically it went down to basically routing between the airports, the train stations, and between the cities. And then, so for instance, OpenStreetMap routing, it gives the travel times. Also with the flight schedules, you get the times. So basically it's a ranking based on the times in the end. If that explains it. And of course, then for the ranking, we use the minimum time across all these modes which we found. The distance, the distance only to the centroids. So this goes into when comparing the ranks. But we were just for the reachability. We just considered, okay, if it takes like 1 hour to go from A to B, then that's it. That's for the reachability, the aspect, regardless of how long it is.
I think this is really a goldmine in the sense of giving us an idea of how things are connected in Germany. I was wondering, you might have thought about it more deeply and rejected the idea, but would it have been possible to compute the overall total mean time it takes to travel 1 unit in Germany and then normalize this matrix so that you can see which places or pairs perform worse than others and which ones are better than others, so that you can that the colors of the matrix tell me the red areas are the sort of like the remote places and the green areas are the highly connected places or something like this.
Yeah, no, it's a good point. No, I think we were considering also distances now that I mentioned it, but in the end we went for the time, so you can, so now I need to think. There's many things which could be done, right? I mean, of course. Like traveling by plane is probably costs more than traveling by car, or well, sometimes you have very cheap offers if you book early, so maybe that's not the case. So it varies greatly, actually, this thing. But in the end, it was really about, okay, we want to compute the reachability and
brilliant, yeah. And I mean, you have got the data set now, you can do anything you like, right? And the other thought I had is that in genetics, there's an algorithm that permutates the rows and columns of a matrix so that you cluster similar things. And that might give you a really interesting picture of which cities are where.
That's a very good idea to apply kind of post-processing to cluster it to make it to provide a better a simpler graph of it where related things are grouped. Yes, indeed, yes.
All right. Well, thanks a lot, Klaus, for your talk.
Thank you.
So this is the end of this session. We're moving on next to the poster awards, but before that I just wanted to tell you that if, like me, you haven't been to the Living Lab yet, there will be a group departure in the reception at 4:30, well, after the awards ceremony, so you can all join to go to the ScaDS.AI Living Lab together.
So, I have the pleasure to announce the Best Poster Award. I'm struggling as well with my laptop. Okay. So. So this is super small. Okay. Actually, do you see something now? No. Only there? Yeah. Maybe we wait? No. maybe I just do it in this way. Yeah, seems to be a cable problem. Okay, so I'm doing it without slides. I mean, it's just the poster award. So you have to trust me when I show you the numbers here. So yeah, my name is Sebastian Tramp. I'm CTO of the Essenza GmbH, and since 4 years we are part of the. What do you? Okay. Ja, nee, das. Nee, da drüben hast du USB. Ich habe gar kein USB. So, and since 4 years we're doing the Essenza Best Poster Award. No, it's not coming. Oh. Okay. Stop it. So, and also this year, again, we ask you to vote with your with the small stickers on your badge, yeah. And you did this, so we had 2 categories: the Best Semantic Web Poster Award, which is donated with €100, and also the Best Design Poster Award, which is donated with €100. And there were 12 posters outside, and we received 115 votes in both of these categories. And now I have the pleasure to present the Best Design Poster Awards, and the Best Design Poster Award goes to the poster Korrelieren die Musikgenres der Top 10 der Billboard-Charts mit den Genres der erfolgreichsten Konzerttourneen. Lea Kunz. Lea Kunz. Totally in time, no problem. Yeah, congratulations for the Best Design Poster Award.
Thank you.
Okay. Okay. What about the professors? Do you want to come to the stage as well? Yeah. You belong to Thomas, right?
Yes.
Okay. Okay, so this was the Best Design Poster. Now the next poster award is named the Best Semantic Web Poster Award, and it goes to the poster Learn SparkQL, eine Webseite zum Lernen und Üben von SparkQL-Abfragen bei Justin Kreller, Lambert Klink and Moritz Meister. Bravo. Only 2 of you? Yeah. So, congratulations.
Thank you.
Yeah, congratulations. You can have this. Both also your colleague, Lea, you have to send me an email and then we arrange the money transfer. Okay? Okay, thank you. Yeah, sure. Okay, so now this is also the closing ceremony. So the 10th anniversary of the Semantic Web Day is now over. I thank you all, especially of course, the organization team, but also, for instance, the streaming team who did a great job. And they are not on the web pages and are not on, so we just have to emphasize this. And I also want to thank our internship, Sebastian Plott, there in the lower left. Thank you very much. Okay, so for the rest of the day, you have two options. The first option is you can go instantly now to the Living Lab, which is roughly, I think, 20 minutes walk, so north of the main station. And you can also wait and go to your hotel or whatever and be at 6 p.m. at the Moritzbastei, which is only 500 meters from here. And at the Moritzbastei, we are doing the Essenza Semantic Beer Garden, where you all get beer and snacks, and we can talk and drink. Thank you very much. Sag doch, das ist kaputt. Ja, das kann ich. Da, guck. Keiner versteht warum. Aber auch ich hätte es schon vorher testen können.